See if everyone. Okay, so can everybody hear me?
Mm-hmm.
Skype and everything else?
I'll work on that part. You get that filled in?
Okay.
Does everybody know Randy Howden?
Not yet.
So I kind of gave a quick overview at the all area, but not everybody's there. So Randy was he is part of our chiller group, and he wanted to retire. And MacMiller said, "Hold on, hold on. Let's see if we can keep you around for a little bit longer and pull some of that knowledge out of your head and put you into a role where you can do some training and kind of help out sales and just kind of let you ease out kind of slowly." So that's kind of where this is born from. So Randy and I sat down, we put together some classes for sales, which has been very successful, just to kind of teach the salespeople kind of, what chillers are, how to sell them, so they can go into mechanical room and speak intelligently instead of, poking at things and not know what they are. So it's worked out well, and then we thought, well, let's do this for service too, because not everybody that comes into MacMiller has a background of hydronics or chillers or all that. You walk into some of these mechanical rooms and it gets overwhelming. Like, what are these big machines? I see a lot of bolts, but I don't know what they go to. So that's kind of what this was born out of, is to kind of help paint that picture as far as like different types of chillers, what they're doing. You're not going to walk out of here a chiller tech, but maybe it will spark an interest. Maybe this is something that you want to get into, because MacMiller is growing and people are leaving, and we need to start to fill that gap. So if something in here interests you, maybe you want to know more, we have a chiller group that's what they do, and you can talk to your foreman. And I think Todd's going to be in here in a little bit. He's the chiller foreman, if you don't know Todd Zeller. And you can start to express some interest and maybe get into that group some more. So they're not mean. They're a nice group. They're particular. They've been around a while. They're set in their ways sometimes, but they do need fresh blood too. So there's opportunities out there. So with that, we got Randy. You guys, I got handouts. I'll go get them. I got 10 more. So Dave, I know you want one. I'll go get those. So don't be afraid to ask Randy any questions, and yeah, we'll just go through it. And then hopefully all the people on Skype, I think they can hear. So if they can't, I'll deal with that. So without any further ado, Randy Howden.
So, like Seth said, I retired, but I'm a consultant for MacMiller now. I've got almost 40 years of experience. All of it was in the water chillers. I started at York International for 20-some years and ended up here for the last 5 years. So, anyways, we are a picky group because it's when you're working in a machine room, it's probably the most expensive part they've got in their building as far as maintenance goes, and it's also the biggest energy hog they've got. What we're going to do today is we're going to try and get into the operation of chill water systems, identification of the components, and maintenance requirements on these. We're going to start off with air-cooled chillers and then move on to water-cooled chillers, and then get into some maintenance and a little bit of troubleshooting as we go along. Like Seth said, if you guys have questions as we go along, please ask them, or observations or experience. How many people have any chill water experience at all here? So a few you do. Okay, good. So one question that always comes around is, well, why are we putting chillers in this building? Why don't we just put a bunch of air-side stuff in? And this statement pretty much says that water carries 3,317 times the amount of heat of air for the same space. Metal pipe of water just 1 inch in diameter can carry as much energy as an 18 by 18 inch metal duct of air. So could you imagine if you had, say, a 1,000-ton system? You needed 1,000 tons to cool that building off. How big the ducting would be to get it down into the space. By moving chill water, you have two advantages. It's a small footprint. Most of the time it's isolated. The chiller's in one room or one mechanical space, and then they pump the water to the different floors, to the different air handlers. Chill water temperatures are normally 35 to 55 degrees for comfort cooling. On average, that averages out to about 45 degrees. Depending on what the customer wants to do, if he's looking at dehumidification, you know, you want it below wet bulb, but there are some buildings that they run with a 50 to 55 degree chill water system, which, you know, ultimately they're trying to get a 55 degree air temperature out to the space. So, purpose of the chill water system is to move heat from where it's not needed to where it doesn't matter or can be used. So it's like an air to air, it rejects the heat out in the atmosphere someplace, whether it's with an air cooled, it's through the condenser system with coils, or if it's a water cooled system that puts it in the cooling tower, and you see the steam being rejected out of the top of the cooling tower. These are the different chiller types. On the left, you've got your air cooled, which they're a package unit. They've got the condenser fans, the condenser, the compressor, and the evaporator all in one piece. The water cooled systems, you've got to have a cooling tower or something to reject the heat. Both these chillers have the exact same components as a regular air-to-air system. It's got a compressor, it's got suction line, it's got metering device, condenser, evaporator, all the same components. They look a little bit different, and they're a lot bigger and a lot more expensive. As you can see, like I just said, you got your compressor, your evaporator, expansion device, or any kind of a metering device, and air-cooled is a packaged unit. So this is what an air-cooled system looks like. You've got your air-cooled chillers up on the roof, or they can be outside on the ground someplace. And you got your chill water pumps, and it basically just pumps the water through the chiller, down to the air handlers, and then back up to the chillers. What they use, everything needs to have a control device of some sort. This is what they're using for controlling the water. Like I said, typically they want about 55 to 60 degree air out into the building. So what they do is they pump the water to these control valves. Either it's going to be a three-way diverting, a three-way mixing, or a two-way modulating. By the three-way diverting, the chill water comes in, and a controller sensing the air temperature will squeeze that valve down and send the water back to the chill water loop, back to the chiller, and it'll take what it needs to maintain that temperature. In the three-way mixing, it'll actually mix the inlet and the return to maintain whatever temperature they want, 55, 50 degrees. And in the two-way modulating, it just squeezes the water down to where you're not getting any water through the coil whatsoever. Problem with if they're going on a cheap system where, you know, they're trying to save money, they'll go with a two-way modulating, and then they'll put a variable speed drive on the chill water pump. And that creates a lot of problems because all these chillers require a minimum chill water flow, and if all your valves are two-way modulating, it's going to eventually squeeze the water down to where you're not getting any water flow whatsoever. They're using a delta P on the system to control the chill water pumps, and like I said, as they squeeze that down, pump way down, and you'll start tripping your chiller off on low pressure. It's just like on an air-to-air system, where if you slow your air handler way down, you end up with low pressure and all kinds of operating issues. The same thing, instead of air, we're just using water. So this is a typical chill water coil. You've got your isolation valve, shut-off valve, and the chill water goes down through the coil, through a metering device of some sort, through the coil, and then you got a balancing valve, which usually it's just a hand valve that the balancers come in using. If you can see the Peach plugs, they measure pressure differential across the coil, and that's how they can put in the design GPM. Like everything, they've got design GPMs, and that's how you keep it as efficient as you can. Here's an example of different chillers. This one on the left is, it's got its own pump package and everything, so they can just basically take that and put it anywhere they want and hook up piping to it and some controls, and you're good to go. On the right is, you'll see more of the stuff on the right where it's just a chiller, and they put it up, and they've got to hook up their own pumps and their own flows and all that. Ideally, air-cooled chillers are the best chillers you're going to see out there for rental chillers. This chiller here we're looking at is at the tunnel, I think it's a southbound tunnel of the Roosevelt station for the light rail system they're putting in. We installed these chillers temporarily so they could freeze the water or freeze the ground so they could drill into the wet dirt and without any flooding, and put in the emergency escape routes. They were required to put in an emergency escape route out of these tunnels every, I believe it was 100 yards. So these were on site for over 2 years. They run 14-degree brine, and they just drilled holes through the wall and into the dirt with piping, and it took them about 2 weeks to drop that soil down to where it was frozen. And then they take a big auger and just hog all that dirt out, and then they'd seal it up. But if you're ever on a site where they need some chill water and their chillers are out, there are several different companies that rent chillers, and it's a great option. We've used them, and it saves everybody's rear. It's another example of a chill water system. These tanks in the back, a lot of times with chillers, they have what's called a short loop, where the water goes out through one coil and comes back in, and the water temperatures fluctuate so fast, or the set points drop so quickly that the chiller short cycles. So they put these big tanks in the back to give you more volume. So it takes longer to control your temperatures, and you don't short cycle as much. It's another example of an air-cooled chiller. You can see there's 3 of them there. They're hooked up in series, or excuse me, in parallel. And they'll just stage them on or stage them off, depending on what they need. Usually they'll have a control valve of some sort where if they're not using that chiller, it'll isolate it so you don't get a mix of water at the end. For instance, if you're running one chiller and you've got 3 chillers and you're running water through all 3 chillers, that one chiller may have a 45-degree leaving water temperature, but by the time it mixes at the end, you'll end up with about a 52-degree water temperature heading out to the building. So that's why they put isolation valves on these, to help control that. That's an example of multiple air-cooled chillers. I believe this is Saudi Arabia. These are probably 400 tons each, and there's 1, 2, 3, 4, 6, 7. There's 9 of them, so that's 3,600 tons possible cooling. Each chiller's got its own pump stations, and can get pretty complicated. But you know, it's an example that you can put in as many small air-cooled chillers as you want, and ultimately end up with the tonnage that you need. Advantage of an air-cooled chiller. They're factory package built, so when they arrive on site, they're ready to go. If they come with a pump, which some of them do, you just hook your piping up. If not, then they have to have their own pumps, but they're basically ready to go. They're easy to work on. They're easily replaced versus a water-cooled chiller that's usually, they install the chillers and then they build the building around the chillers. That could get to be a nightmare if you've got an old chiller that needs to be replaced. The factories do have it's called at least at York, it's called a Form 7, where they build the chiller at the factory, water-cooled, then they disassemble it, send it out in pieces, and then we go in and reassemble it in place. That's how you can get the pieces in and out of the door. Another advantage of an air-cooled chiller is you don't have the cooling tower and the associated chemicals that goes with it. That's always kind of a nightmare. You know, depending on the chemical company you use, or if you're doing it yourself, you can have all kinds of chemicals and Legionnaire's disease and you know, a lot of hazardous waste kicking around. What size building uses air-cooled? Any size. Any size at all can use it. As you saw earlier, that one building had 3,600 tons of air-cooled chillers. One disadvantage to an air-cooled chiller is there's a lot more moving parts. You know, but the tonnage ranges on these are 50 to, I think the largest one I've ever seen is 400 tons. And they do go smaller than 50, like in the MRI systems. Those are all small tonnage, you know, 10, 15 tons. Different types of compressors you'll see on these air-cooled is a screw. For instance, screw machines are, there's a lot more screw machines out there now than there ever was in the past because they're efficient and they unload to around 10%. Biggest problems they have is they're quite loud and they're very oil saturated, so if you get a leak, you end up with oil all over the place. When they run, they sound like a Hoover vacuum cleaner. They're very loud. You should wear hearing protection when you're working on them.
What?
They're heavy built. They're long and heavy cast. And when we do the maintenance on them, it's got oil in it, so we recommend sending out an oil sample. I'll get into that after a little bit.
And we have a screw compressor class coming up in April. I kind of talked about it at the all area. But AC Components, who rebuilds screws, because like those screws, just like that's an 06D. Remember we did that compressor class last year? Those are pretty cheap compared to like a Bitzer screw that was up there. So there's companies that rebuild them. Well, they're going to come out here in April. I think it's the second week, and we'll do a teardown class here. There'll be two of them. There'll be a daytime class for Chiller Group, and then an afternoon class for everybody else. There's going to be one at the hall too, so the hall's going to offer that as well. So it'll be a Monday, Tuesday. So if you can't make here, you can go to the hall, or we'll figure something else out. But it'll be good because break those things apart. They're shipping some cutaway too. The cutaway is like $1,000 to ship here, but apparently it's really nice. So I hope it's worth it.
It's really interesting. If you guys have the chance, you really should go see it. Just how they work. They've got two opposing helical screws in it, and they inject oil in between the helical screws, and that's what creates a seal between high side and low side. With that being said, you need oil separators to get that oil out of the refrigerant stream before it actually goes out into the condenser. And some of the smaller screws have oil separators built into them. Some of the larger screws have oil separators that are just off the discharge line. Goes through the discharge, and then it goes in an oil separator. And usually it's a two-stage, and they can get out about 99% of the oil before it actually goes out and hits the condenser. But it's interesting to see. A cutaway is always nice to look at because you can really see how it works and how it loads with slide valves. A slide valve basically just enlarges the hole that allows the refrigerant to go into the compressor. And as it unloads, it just shrinks the hole down, and it's interesting to see it. So you guys are all familiar with these recip compressors, old technology, almost obsolete. I don't even know if a manufacturer's building chillers anymore with semi-hermetic compressors. The old Carlisle compressors are pretty solid, but they're not super efficient, and they don't stage down as well as a screw does. They are fairly quiet depending on the manufacturer and the size. And again, they've got oil in them, so we recommend an oil sample and an acid test annually. Depending on the size, typically something like this, you'll just use the Sporlin test and test it on site and look for acid, because if you do have moisture in the system, that does develop into acid. So That's about it. Like I said, you're not gonna see a lot of these around, and as far as rebuilding these, you know, it costs more money to buy the parts, tear it apart, and put it back together than it does just to pull the compressor out and replace it with core charge. Here's a standard scroll type. A lot of the smaller air-cooled chillers, up to about 100 ton, 120 ton, they'll use scrolls. See, these are 2 scrolls hooked up in one circuit, so they'll stage them on. So, for instance, if these are 15 tons apiece, you can drive it down to 15 ton, or if you got a bigger load, it'll run up to 30 ton. If you replace one compressor, they always recommend replacing the second compressor, just because of the acid content that will go into the first compressor. A lot of customers don't like to do that. It's expensive, but you know, the sell point is, well, it's not going to be long before that second compressor goes out, and then it'll take out the new compressor as well. So you're saving money. If you notice on top of these twin compressors, there's a steel bar. Usually there's a big sign on it that says "Do not remove," because as one starts, they tend to torque each other, so you'll start breaking all your piping. So make sure you leave that steel piece on, because that way they don't torque, they move together, especially when you're dealing with the piping that's involved in that. These are, have any of you ever seen a turbo core compressor or magnetic bearing compressor? They've been around for a long time, but they're getting more and more popular. They're really quiet. They have no oil in them, and it's usually encased. These plastic, on the compressor itself, you see the plastic on the top. Right here, the plastic on the top and the plastic on the side. On the top, that's your variable speed drive, and on the side is all your modular boards. So there's really not a lot you can do on these other than visually inspect your wires, make sure everything's tight and connected. These will spin, I believe they'll go up to 150 hertz, which I can't tell you how fast they're rolling, but they got to be 20,000 RPM probably, and they're controlled. They're magnetic bearings, so they have, each bearing has got 4 proximity sensors, one on top, one on bottom, and then one on each side. And while it's running, it's looking at where the shaft is actually located within the bearing, and adjusts the magnetism on that bearing as it's running. Biggest problem with these is if they surge, they'll start hitting the bearings and it'll wipe them out real quick. So they've still got, they're decent compressors, but they're really expensive to replace, and there's really not a lot you can do them. You've got to be trained on them, and you've got to have a program. Yeah.
I didn't mean to interrupt you. What do you mean by surge? I was going to ask you.
So a surge is when you're running and your discharge pressure gets too high. For instance, say you lose a fan and your discharge pressure gets too high and it can't overcome. So surge is basically your refrigerant discharge gases going backwards, back into the compressor, causing the compressor to free spin, and then your impeller will grab hold of it again, and so your amps will be bouncing all over the place, and generate a lot of heat by doing that. And so usually with these turbo cores, especially if they sense any kind of a surge at all, they will just shut down, just to protect themselves.
Is that pipe too big to put like a check valve on it?
They do have a check valve. They do have a check valve, but it's still, it'll freewheel because it can't overcome the pressures. Or even if your suction pressure gets too low and your discharge is too high, it's like have you ever seen a water pump cavitate? Mm-hmm. Same exact thing. It's basically the impeller's cavitating in itself because it can't overcome the pressure.
Yeah, if you think about your standard compressor, like you work on every day, a recip, what's your compression ratio on one of those? Like, think about your suction compared to your discharge. 5 to 1, 4 to 1, right? Like R22, 68 in, 200 out, something like that. What's a compression ratio on a centrifugal?
It can be, well, it can be about the same. You can be running with.
They can be, but as you slow them down, you gotta think you're not, like with a piston's positive displacement, right, for the most part. Centrifugal isn't. It's you're basically grabbing fluid and flinging it out like an impeller of a pump. And so because of that, because it's not positive displacement, you actually can get, like what Randy's talking about, where fluid, the gas can go backwards through it, and that's the surge. If you ever walk into a mechanical room and hear a big centrifugal, like, well, you'll know when you hear it, you know, surging. It starts this kind of pulsing.
Yeah.
It can't overcome the pressure. It starts going backwards. Where you can't do that in a piston. You can't do that with a screw. Like, but you can do it with a centrifugal.
Yeah, with the positive displacements, you can't do that, but you end up, on a positive displacement, either you'll break the rods, or you blow the relief valves, or something. It'll keep running. On these, they'll just stop pumping, basically. And if you got questions as we go along, great, ask them, because now's the time while we're viewing all these.
How does it sense that to stop when the head pressure gets too high? What is it using to sense when it gets in that surge
They're
situation?
using a surge curve. It's called surge curve. They're looking at suction pressure, they're looking at discharge pressure, and they, on some of them, like the Yorks with variable speed drives, they actually have it's called a surge map, and it'll actually drive the compressor into the surge. Now these are magnetic bearings, so it'll actually drive the compressor into the surge. It'll sense the surge by looking at the amps, and it can tell because the amps are going up and down. So then it'll boost the speed, and it'll close the vein assembly, reduce the amount of refrigerant flow going through that compressor until it comes out of the surge. It'll map that and remember that, and it won't allow it to get into that situation again.
So do these have some kind of like computerized interface where you can interact with it, see what's like
Yeah.
if it's locking itself out? I'd imagine, because that seems like a lot.
Yeah, with the turbo cars especially, if you've got their program, you can see their surge curves. You can one thing to look at is pressures, suction and discharge pressures, and they know when it's going to surge, so they try and keep it out of it. And usually, like I said, most surges occur when you're on a variable speed drive and it's slowing down too much and you're trying to move too much gas, and it'll start to surge. So then it'll boost the speed up and it'll close the veins, the refrigerant flow, and take it out of that surge. So as time goes along, these chillers are getting a lot smarter.
What happened?
Just let it.
Did it happen when I left?
No.
Keep talking, Randy.
Okay, so, can you see that?
Yep.
Kinda?
It's there.
Okay, so there's two different types of evaporators. You got your brazed plate and you got your shell and tube. Bigger chillers use shell and tube, but smaller chillers, because manufacturers are always trying to save a buck, they've shifted to the brazed plate. Brazed plate, it's smaller, it's inexpensive. It's smaller, it's inexpensive, and it takes up a lot less space inside the chiller. It's a lot lighter. Yeah.
With that brazed plate, is the only way to clean it chemicals?
Yes, that's basically the only way. We've got a tool that we use on the on different chillers that you actually have to disconnect the water piping and hook this tool up. It's got a little pump in it, and it kind of surges. And then we've been using rid lime and pump it through. It takes about 4 hours per heat exchanger. Now on an evaporator, most evaporators, chill water systems are closed loop, so they'll put in a chemical and an inhibitor to keep bacteria down and keep corrosion down. So you shouldn't have any real issues with your evaporators. Where you will have problems will be on your condensers, if they're using brazed plate on a water-cooled chiller. You'll have issues with that where you'll have to do it, yeah.
So I know they're doing some of those like micro channel brazed plates now, like condenser water stuff. And common practice for us is in normal AC world is back flushing condensers. Is that recommended on micro channels since they don't have any kind of screening or protection, you know, on the return water if we're back flushing?
Usually, you know, that's great for solids, but a lot of times on a water-cooled chiller, you're gonna end up with some bio, some growth, and, you know, you can back flush it all day, it's not gonna.
So if we see it, it's test it.
Yeah, you know, on a condenser, brazed plate condenser, they've got strainers, and honestly, any customer I've had that has brazed plate condensers, I always recommend them putting a closed loop. So their condenser system, they've got a shell and tube someplace where they're running cooling tower water through that, and then they got another pump that runs the condensing water for the chiller, so it can still be a closed loop, so you never really have to worry about it. Children's Hospital has, they've got 6 multi-stack chillers, they're all hooked together, and it's on their cooling tower, and it's a mess every year. Literally, we've had to clean it twice, and this machine's only 5 years old, and every year I've had to clean those strainers at least twice, pull them out, and, you know, it's kind of a big task. It's a 300-ton chiller, and it's like 6 different strainers you gotta pull out and rinse them out. So if the customer's got any money and wants to save money in the long run, that's what he wants to do, is put in a closed loop. So on the shell and tube evaporator, you see on larger tonnage chillers and even on a lot of air-cooled still, they're still using the shell and tube. I like them a lot better. Problem with the brazed plate is it really screws up with your water flows and your pressure drops and all that. And there's no refrigerant forgiving. Basically, it makes it into a critical charge. Where shell and tube, you've got a fudge factor. You know, when you're talking with a machine that holds, you know, 500 pounds of refrigerant and it's critical charge, that's, you know, it's pretty easy to show up with 100 pounds of refrigerant and just throw it in and say, oh, I'm good, and then all of a sudden you're flooding back. And so if you're working on a brazed plate evaporator, you really got to be careful on your water flows and make sure your metering devices are working correctly, because it is easy to go off on low pressure, and it's easy to, that's a pretty common problem on these. Another problem with these is if you ever freeze up a machine, basically drop your suction pressure below freezing, they will break, and they break very easily. Versus the shell and tube, they'll break as well, but you can get a lot colder before the tubes will actually break.
Why is that? Just the type of metal that's being used?
Just the design of it. There's no, you know, it's thinner. It's all about heat exchange, so the materials are thinner. And as you know, when water freezes, it really expands, and so it'll actually split inside. And you can't even tell until I had one 410A chiller, and they broke their evaporator, and nobody knew it until they couldn't figure out why they were blowing all their water relief valves on their chill water system. Well, the 410A got into the chill water system and just played havoc on it. You know, and once you break an evaporator and fill your machine up with water, you've pretty much destroyed that piece of machinery. If nothing else, you've just created a big bill, because it's really expensive to dehydrate them and replace the bundles and all that.
Do you have to completely replace all the oil in that? Like, how are you going to get all that water out of?
Oh yeah, you got to drain it.
POE.
Yeah, you got to drain it, and then you've got to get all the oil out and evacuate it. And you know, there are companies that come through and they'll pump refrigerant through it, and then they'll dry the refrigerant out and then pump it back through until it's coming back clean.
You do something similar, like when you have a burnout, have to install the suction line dryers. and all
Yeah,
that
it's a nightmare, you know, and a lot of times because the machine's been running with the water in it, it'll destroy the compressors. And, you know, it'll eat away at your motors and it's expensive. And so when we get into troubleshooting, we'll talk a little bit about moving gases around and all that stuff, but,
And I know from experience, a screw will pump water for a while.
it will. It will, yeah, absolutely. I was working on a job and it was at a mill, Boise Cascade, and all their chillers were over in the mechanic room and they were operated by the operators up in a room. And the machine shut down and nobody went up to see why, they just restarted it. And it started up, ran great until it seized up. And what had happened was they broke a tube, the machine went off on, I don't know what it went off, low pressure or something. They reset it. By this time the water had displaced all the oil and the oil pump came on and it was actually pumping water, developed pressure. And so the machine started up using water as a lubricant, and that's really not a great lubricant. And it was a 1,500-ton machine and it seized it up tight. That was a difficult repair. So this is an example. I threw this in just so you can see what a tube and shell looks like inside in a water cooled. That's the evaporator right there versus I don't know if I put I didn't. Versus a brazed plate, it's that shell there is probably maybe a 100-ton shell. A brazed plate would be about that big, considerably smaller. Well, like I said, manufacturer using it because it's just a lot cheaper to install it, and they can sell their product for a lot cheaper. Once it gets down the road, they really don't care if it's gonna, if it's a nightmare to run it or whatever. They're just trying to sell their product. Condensers and fans. This is the latest and greatest condensers they have out there. It's called a micro channel. You can see that right there is where the refrigerant's going, and then it's like a radiator in a car, basically. It's all aluminum, and they're disposable. You can't repair them, and they leak often. Because of the expansion and contraction of the material, they'll spring leaks. Usually right along in this area right here. And they're expensive to replace, but we've replaced a bunch of them already, and they're supposedly more efficient. You don't need to have as much refrigerant in the machine because, where you've got a condenser with the tubes in it, it holds a lot more refrigerant versus these. When you're maintaining these, you only want to use water. When you're using your pressure washer, use a cheap pressure washer from Home Depot or something, low pressure, and just go over it with water. You don't want to put any chemicals on this. The chemicals will sit on there and it'll start etching the aluminum and it'll start eating it away.
I've never broken down how those microchannels work. Where's the refrigerant flowing? I see like the kind of fins. Is it the horizontal?
This is a header.
Yeah.
And then right in here, the refrigerant's actually going through these.
Okay.
Nearly said that, Joe.
I was getting coffee.
And it's coffee. So that's pretty standard anymore. Most of the manufacturers are going with that style because it does take less refrigerant and it is more efficient. But like I said, you can't repair them. They're basically throwaways. And sadly, unlike copper, you don't get as much money for scrap out of them. You need a lot of money on scrap material, I'll tell you. When you, if you're retubing a big chiller, it's not uncommon to get 5, 6, 7,000 pounds of copper out of it, and it's all clean copper. So,
Which always goes back to the job.
well, when I was at York, I was writing all the quotes. So I always put in that we're saving you money by keeping the copper. And actually, what you're doing is it's giving me motivation to come in and retube your chiller because it's a lot of work, And I'm always, the only thing that keeps you going is that new TV I'm gonna get, you know, something like that.
That's awesome.
So we've already seen this slide. It's just, again, it's the components, they're all the same components as air to air. You know, pretty cut and dry. So when you're working on these, the nameplate will tell you everything you need to know. If you need to buy parts, or you need to call the manufacturer, or you need to, whatever, they're always gonna ask for the model number and the serial number. Now this is a York, so the model number is, whoops, I hit the wrong button. Sorry. Back up a bit. There it is. Hold on. There we go. So model number here, this is a York plate, and then the serial number would be down there. But it tells you the amount, the type of refrigerant, the amount of refrigerant. You want to make sure that you read the right slot, because a lot of these nowadays tell you refrigerant in pounds and refrigerant in kilograms. So make sure you take note on which line you're reading. Yeah, we could really overcharge one drastically if you look at the wrong line.
Or undercharge.
So it also tells you your voltage, and most of these manufacturers, if you're ordering parts, you're going to want the serial number off that. So this is an example of chill water pumps. Can be in the packages for the air-cooled chillers from the factory. May be located someplace else. If you're working on air-cooled, usually the pumps are not next to the chiller. Usually all you see is a couple of pipes coming out of the ground, and the pumps are typically in a machine room someplace else. So pumps are always insulated to prevent sweating and from absorbing heat as it's running through the buildings. And that's how you can always tell if you walk in a machine room and the customer say, well, yeah, my chill water pump's leaking. You know, don't walk up to the uninsulated pipe, because that's not your chill water. You want to look pretty smart when you walk up. So look for the insulated. Also make sure it's not the boiler. A lot of these pumps will have variable speed drives on them anymore. I don't really like to see chillers with variable speed drives on them on their primary pumps, because the chillers are designed for X amount of water to go through it, and if you start messing around and getting your chill water flows out of range, you're going to have a lot of operating issues with that chiller. So if you go in and you see a chiller that's running on low pressure or low pressure control, make sure that that drive is running, or make sure you've got the right pressure drop across. Using the nameplate we just saw, you can call up the factory and find out what the design pressure drop is on this, in each individual chiller. Bigger chill water systems are going to have, it's called a primary secondary loop. The primary loop is each chiller's got its own designated chill water pump running full speed, and then that goes through the chiller, and then it feeds into the secondary loop. And the secondary loop's got its own chill water pumps, which feed chill water out to the different buildings. You see that on larger systems. It's really a much better, and that's where you're going to see your variable speed drives on that style, would be on the secondary loop pumping out. And a lot of times they're looking at delta P across the buildings, or they're looking at GPM. They want to maintain X amount of GPM. So
I have a comment on those too. On that back slide, Randy mentioned water leak, and it's happened before. I think I might have gotten bit by it once. But these chill water pumps, you know why they're insulated, right?
Hey, you just said.
Huh?
Hey, you just said.
Insulated to prevent sweating or absorbing heat.
Right.
Yes.
What about this part right on top of the volute where the shaft goes down inside these supports? You think that's insulated? Or do you think it's cold? It's cold, so you get water that pools up in there just naturally. Don't mistake that for a seal leak, and then go tell the customer, hey, you got a pump seal leak, we're gonna fix, and then you fix it, and then what's it gonna do again? It's gonna leak again? Well, it's not leaking, it's just condensation, so just,
We've got a customer that swears he's got a chill water leak on one of the shaft seals. He's got 4 pumps, and we've replaced, just to quiet him down, we've replaced shaft seals, and it's just, you know, it's sweating. He's running with 45-degree water, and it's on a, you know, relatively humid day, it sweats and it drips water down, because that's the one area that is not insulated. So, but like Seth says, you want to make sure that it's not condensation, it's a true leak.
and there are some pumps, especially fire pumps, that you'll see that are designed to leak, and you'll see them pipe, you'll see a little pipe.
Lubricant.
Yeah, it's a lubricant and a coolant, exactly.
Exactly.
And so pay attention to, you know, look at the design. If you see a little drain coming off of it going down to the floor cup, then, you know, maybe it's supposed to do that. They'll be tightening it down the bonnet or, you know, trying to stop it, you know, just arbitrarily. It happens.
So this is what chill water is being used for. This is the, have you all seen air handlers? You know, it just, they just pump the water to the air handler someplace in the building, and they extract they add heat to the chill water and cool the airstream down with it. This is kind of a complicated looking air handler, but it's the same thing. This has return and supply. It's also got humidification in it and a heating coil. So, you guys have all seen that though, so. This is an example of poor maintenance. This is up in Everett.
Of course there is.
And you can see that's basically from salt water. It's relatively close to Puget Sound. And I actually, when I was on site, I just ran my hand across the coil and it literally just fell apart. All this stuff, it just landed down there on the ground, and as you can see, that chiller hadn't run for quite some time.
Still not running?
Still not running. Matter of fact, I stole all the controls out of it and sold it to another customer, so.
We didn't take the cost.
Controls were still good. So,
Steel controls.
hey, you know, it's about making money for the company too.
Yeah.
You know, and then if you get the permission of the customer that things have been deadlined, hey, you know, you mind if I take those controls, and you know, you're doing him a favor because he knows he's not gonna run it anymore anyway. So yeah, sure, go ahead and take them.
Take all the copper off of it too?
No, I didn't do that.
Yeah, rub
You
those
saw the
fins
coil
off,
still
cut
sitting
them.
there. I don't know if I wanna cut those out, tell you the truth. So get any maintenance of these chillers. The outdoor units, you know, we're still talking air cooled here. When cleaning the coils is important. You know, if you can't reject the heat, you're not gonna be efficient when you're running. So cleaning the coils should be done annually. And when you clean them, like I said earlier, you wanna just use a low yield pressure washer and no chemicals, no acid, nothing like that to clean these coils. The only thing that's being introduced to these coils is dirty air, that's it. And so a pressure washer should be able to get that all off. The only time you'd ever really want to use any kind of a cleaner would be if you got an oil leak and you're trying to clean that up, but you're going to be repairing that anyways on the older style condensers. Chemicals for water loop, that would be on your chill water loop. We don't do chemicals here, we use Chemtech, and so depending on your customer, some of them are gonna want, they've got their own chemical companies, but you just wanna, you know, touch base with the customer and say, you know, are you guys taking care of your chemicals? You know, is it up to par and all that? Glycol. These air-cooled chillers, keep in mind, they're all outside, and if it's cold out, you can very easily break your evaporator. So,
And you know, you can get a spectrometer too, you can check the freeze protection.
Absolutely.
And, you know, you open up the water and it's, you know, doesn't look clear.
Yeah.
There's a problem, you need to talk to your customer.
yeah,
Because, you know, not all chemical countries are equal.
yeah, I carry a refractor, and every job I went on that was outside, it doesn't take any time at all to pull a sample, just take a little drip out and then see what it's at. Should be good to, at least 15 degrees, and at least if it's good down there, you're not gonna get a hard freeze. It'll just turn into kind of like a slushy. So,
On that, it's also usually serving an outside air unit, so that it may have cooling, so that coil could be exposed as well.
exactly, if they're drawing in outside air, I don't know, how many coils did we have break this last cold stretch?
Oh, we had a few.
At least 3, I know.
Yeah.
Yeah,
We had a few.
yeah, that's because they're not doing their glycol.
Yeah. That was controls and freeway valves.
Yeah. Yeah, same thing though. We've got a customer over in Quincy that,
Well, if your freeway valve shuts water off to a dry cooler, and you don't have any glycol in it, or glycol in it, you're done.
yeah, no water flow. At least if you got some water flow, it's gonna, move it along, but if it's just sitting idle, it's got a great chance of freezing. We've got a customer in, Eastern Washington, in Quincy, that, it's Yahoo, and they don't believe in using glycol in their lube. They think it takes away from the heat exchange. And so, consequently, they've broken a few coils, and, they're, hard to replace those coils, I'll tell you. So anyways, expansion tank, every chill water system's got an expansion tank on it. That's to maintain an even pressure on your system, whether the system is warm, sitting idle, you got 70-degree chill water, or you got 45-degree chill water. Water expands as it heats up, and so the expansion tank will absorb the expansion. If you come up to a customer and he says, hey, I'm running with, I noticed my chill water pressure's up, 50 PSI or 40 PSI or whatever, from where it should be. The first thing you want to check is your expansion tank. Older expansion tanks just have an air cushion on them, and usually there's a sight glass on the side of these expansion tanks you can look at, and most of the time you'll find they're full, so you can just drain the water out and displace it with air. Newer expansion tanks have a diaphragm in them with a set pressure on it, and so you can check that pressure and make sure. But if you find your chill water pressures are climbing, it's typically because your expansion tank needs some attention. You want to do a refrigerant visual leak check. A lot of customers, they don't want you to take the time to leak check. They don't want the money in it, so it's pretty simple on most systems other than a turbo core with oil. Just look for oil leaks, and that's the best way you're going to find it. And if it happens to be running, of course, you can check your sight glasses like any other air conditioning system. Check your sight glasses, check your superheats, all that, but some sort of a refrigerant test. You want to do an electrical component inspection. Basically, that's, of course, you got to suit up with all your safety gear. But then you open the panels and you just look for discolored wires. You look for, burnt contacts. Just the basic stuff that you're always looking for in all these control panels. Nothing different there.
Hey Randy, on those microchannel things, does it matter if you're shooting the water down or up when you're painting those coils? Because there's that one Cirrus that it's pretty high up there. Do you have to shoot the water at a down angle, or does it matter if you're shooting up or down?
Well, you just want to make sure you don't collapse those fins. That's the big thing. So like on the channels, I don't think it really matters. As long as you're knocking that dirt loose, because unlike a copper fin, where you could actually flatten the fins out, it'd be difficult on a microchannel to do that. So,
Okay.
But yeah, I don't think it matters whether you're going up or down. Just try and get the dirt off as best you can.
They make wands and stuff that shoot straight at it, so that you're not shooting to the side, or you want to shoot straight at it.
Yeah. But also remember, you've got your outer coils, and then you got your inside coils, and you want to make sure you clean all the coils, not just the half you can see. So, if you want to do an operational check, that's basically run the machine, check refrigerant levels, oil levels, superheats, pressures, temperatures, all that, amperages. Check your glycol. Like I said, you want it, I think 30% is pretty standard, which gets you down to 10, 15 degrees. And then you want to make sure you climb up on the machine and, of course, use your fall protection. And inspect the condenser fan supports and blades. They will fatigue and they will crack.
You said you're running yours, is that because a lot of your chillers are running a brine solution? Is that why you're going down so low, or?
What's that?
On your chilled water loop, you said you're taking it all the way down to 10 or 15?
Well,
Is that because you're the systems that you're talking about are running
No, this is just
really cold, or
ambient freeze protection. That's why you check your glycol. It's just for ambient freeze protection. Like this cold snap we had on an outdoor unit, if the water's sitting idle, it will freeze.
Right. Well, I just hadn't heard it on that one. I mean,
Usually,
we always had 22, but
on
I didn't know that
yeah.
it changed. I mean, you got lots of experience, so
On a brine system, well, what'll happen is
you just lose your efficiency as you go down further. Right?
Yeah, if you
And
get too much glycol, you lose efficiency.
to get down that low.
Right, but as time goes on, the glycol, it will lose its, it'll break down, and you'll lose your freeze protection, or it'll develop an acid, turn into an acid. Also, if you have most chill water systems have water makeups on them, and say you got a leak over here someplace, small leak, and as time goes on, you're making up water in your chill water loop, it will, weaken your glycol. So it's just something that doesn't take long, that you should do annually when you're doing that. And then back to the condenser fan supports and blades. They run fast, and they will fatigue. The blades will break, or the supports will break, and you just want to make sure that you do a close check on them, because if you got a blade that goes through your condenser, it's a big repair. So, and customers don't like that too much. So we do oil samples annually, screw or recips, once a year. Depending on the size of the machine and the quantity of oil in it, we'll either use one of these Sporlan test holes for a smaller system, or we use, I can't remember the name of the oil company, but we
Research.
yeah, we pull samples and send it to them on the larger systems. So service troubleshooting. Say for instance you get a service call, and the first thing you want to make sure is that you've got a signal from your building automation system. I can't tell you how many times I've showed up where the customer says, yeah, my chiller's just not running, and you find out that his automation system is keeping it from running. Just look for a Rebe, or with a little indication light, or there's always a relay in the control panel someplace.
Common one, rib relay, light on it, right?
Yeah, you see those a lot.
Anybody wanna, there you go, Dave. I can see you wanted to get that. Oh, Van 3820's got its lights on, by the way. Anybody 3820?
It's not me.
No, I'm not. I don't know why I'm looking.
You got one light on.
Only one?
Anyways, make sure you got a signal from the automation. Make sure you got your chill water pump. Make sure your flow switch is made. Most of these panels nowadays, you can go and review the history on them. That's makes diagnostics really easy. Make sure you go check for your go through your automation and go through your alarms. Probably 75% of the service calls that we go on are not unit related. It's related to some other thing, the chill water pump, automation, cooling tower, something along that line is causing the problem. So the different types of flow switches, this is you see this a lot. This is just a paddle switch. Old school, pretty solid. The problem is they've got these paddles on them and they break. And, you know, over time, they will break. It's a fact. And so you can have all the flow you want, you're checking your DPs, differential pressures across the unit, and, you know you got flow, but your flow switch isn't made. So, and that's a really important safety, so you don't want to jump it out. If you jump it out and then you do lose chill water flow, you're gonna freeze your machine up. Or it's at least gonna go off on low pressure. But, so that's like jumping out the high pressure switch. You don't wanna do that either, so. Just, you know, if you got a bad flow switch, it needs to be repaired.
Is there anybody that hasn't replaced one of these switches before? Joe, and Laura? So when these, I don't have a brand new one, but when these things come in the box, it's the switch, and then these paddles are loose, right? And you install these, you stack them based on the size of your pipe. So if your pipe is 1 inch, maybe you just use this little one. If it's 2 inch, you put another one on it. If it's 2.5, maybe you end up cutting this one down, and there'll be a little chart on there. You kind of line it up and draw a thing. Shane, right? Yeah.
You talked to us about this before.
Okay, good. Did you just wait?
Are they riveted or what?
No, they're, so what it is you cut them to the size, and then you put them on this, you can see here there's an arrow, so the water's coming this direction, and it bends the plate down. So when you stack them, there's one little screw right here, and there's a little stud. So the paddle, well, hand it to Jason right there. You'll see. And then, but it's important, and I've seen this, I'm sure Matt's seen this, Mark's probably seen this, somebody stacked them backwards. You need to stack them from smallest to biggest, so it gives it some support on the backside. Because if you do it the other way, which happens a lot, unfortunately.
They just curl?
Yeah, they just curl back. The other big thing that happens is somebody will cut these too long, or like that one was a crappy cut. It'll catch a corner on the pipe. You screw it in and it catches the pipe in the bottom, and now it can't move, or it hangs up. So it's important when you're doing these, follow the guide and stack them the right direction. And also make sure the screw's tight, because otherwise it works its way out, and then you lose all your paddles. And then what are you gonna do? You're not gonna have flow, and you gotta call Randy, come out and tell you did that thing.
So how do you get the paddles out of the system?
That's a good question. Is it like a strainer that catches paddles?
Where do they end up?
Construction strainer, maybe.
If you're lucky, usually they end up in the machine, in the chiller someplace, in the barrel. They'll rattle around in there and, you know.
Until they corrode away, or what?
No, they just stay in there.
They just disappear. Another problem you'll run into when you're changing these paddles is, when they've installed the throttle that goes on, they haven't cut a big enough hole. So somebody had to file down that paddle to get it in there, and now you've just weakened it, you know. So happily, this style of flow switch, it's still out there, but we're getting into the electronic flow switches nowadays, they're a lot easier and they're a lot easier to repair.
Do they not have anything physical? Oh, yeah, it's right there.
Right there.
Yeah, probe.
No moving parts.
Yeah, there's no moving parts. What this is, it's basically a little heating element, and it's measuring flow by heat rejection. And so if that's getting hotter than it should, it'll tell you, and they base that on, you know, heat rejection equals flow. And so depending on how you set it up and all that, can tell you what your flow rates are. And the only maintenance you really have to do on these, and it's rare, but you may have to pull a probe out and take a Scotch-Brite or something and clean that probe up.
Not sandpaper.
Well, you can use sandpaper, but I really wouldn't, you know, unless that's all you got. I mean, I've used my knife and scraped scale off before, but Scotch-Brite works best. And just clean that off and put it back in, and it should work just fine. But yeah, these are and if you're ever on a job and you see they got paddle switches, try and sell these to the customer, because in the long run they will save money. You know, if you got for instance, a paddle flow switch, and a lot of times they'll put these flow switches up on the horizontal run after the valves or before the valves. So you got to drain your chill water system down to replace the flow switch. It's kind of a pain, and it's kind of expensive. So I'm glad they're coming out with these. All right, so we're going to get into.
Yeah, let's take a minute. Let's take Ken, or something before we go over to
Sure.
chilled water, or to water cooled. But one thing I wanted to show on these real quick, if you go back one, if you haven't seen these flow switches, as the water flow, as the GPM increases, these lights will come on, and it kind of shows you. And they'll be red normally, and then there's a green one that lights when it hits the set point. So you'll set it like Randy or somebody sets it when they put it in. Because say the chiller needs 700 gallons per minute to operate, this thing will read down to maybe 20 gallons per minute. And which is nice because these can report out to BMS of some kind too. But you'll walk up and you might see the lines and think, oh, I got flow, but maybe it's not enough. So it's important to know how these things work and know that there'll be one light that's a different color, and that's your set point. So if you ever walk up to a chiller and it's not running, and a lot of times, like Randy said, most of the time it's flow or it's something else that's causing it. It's not the machine. But look for the set point. Look to see if you're getting up to that set point. And then see if maybe say you can go the other way too. You can have too much flow. Because what do you think a problem with too much flow might be through a chiller? Yeah, you can start to wear out your tubes. You're not picking up enough heat possibly through it. You're just kind of throwing stuff off. So yeah, absolutely. But yeah, those are great. They're really nice.
We've sold a bunch of them too.
Yeah.
Because they're really not that expensive in the first place. And you know, if you've had replaced, I've seen buildings where they've installed a flow switch in the wrong spot. It's supposed to be, I think, 3 pipe lengths or 3 pipe diameters from the nearest 90. And they've installed it incorrectly. You get a lot of turbulence, and it'll snap those paddles off often. And you know, for the customer, it's downtime and it's also repairs.
How do you test that, Randy?
Test this?
Yeah, the probe, say that the probe gets dirty or.
Well, so if you know you got flow, and it says you don't have flow, first thing you want to do is check to make sure your probe is clean. Put it back in. If it still says it doesn't have flow, you want to go through the recalibration of it. And you know, that's where Google's nice, because you can Google it and it'll tell you exactly how to go through the calibration of it. And if that doesn't work, of course, once you check voltages and check this and that, then it's probably failed.
But what if they have multiple power? You know, is it 24, 120?
It depends on the manufacturer. You know, and it'll tell you the range. There's some of them. I think the IFM effectors are anywhere from 24 volts to 115 volts.
And you said they were fairly cheap. What are you calling fairly cheap? Couple $100?
$200,
$500?
$300 plus installation. You know, of course, then that's for the switch. Then you got to buy the cable, and then you got to buy the length of probe you want.
Right.
So you know, but yeah, $200, $300, $400 is.
Who are we sourcing from?
I'm not sure who we get them from. I think we might get them right from IFM Effector. Seth, you know who we're getting these flow switches from? Proctor Sales?
Yeah, maybe. Steve Gordon. Not really sure.
Steve
Gordon.
Yeah, that's who I get them from.
This kind of a little thing, I guess, but I noticed that the paddle switch was male threaded, and that appears to be female threaded.
Well, so this goes in a.
Is that an option, or is there a different assembly that you hook it up to?
It's male threaded as well, but then the probe, so it's like a well almost, but it's not. But you screw in the receiver.
Okay. So there's a receiver that comes with it. You don't have to like
Right.
take the section out of the pipe or.
Right, it's an assembly, and what I've done on the ones I've installed is, because nowadays most chillers have got electronic displays, you know, electronic temperature displays, but they still put the old thermometer on the end of the piping. So what I've done is I've actually taken that thermometer out and put my receiver in there, and then the probe, it's a compression fit.
Okay.
Put it in, and it's just a compression fitting that holds it down.
So if you had to pull that out and clean it, once you have the receiver in there, you can pull it out and clean it and not have to drain the system out.
You gotta just remove pressure.
Okay.
Yeah, just, you know, isolate it, and if you're installing them, you wanna make sure you install them someplace where you can actually isolate it and do that. So isolate it and just drain the pressure down, that's all you gotta do. If you get a little bit of water on the floor, as long as you clean it up, it's not a big deal.
Most of the time, wherever the paddle switch is, you're generally isolated.
Pardon me?
So wherever the paddle switch is at, you're generally isolated. You know, unless it was
Usually, but you know, it's amazing,
I'm not gonna say everywhere, but I mean.
there's several out there that
80% of the time it's the same.
and you'll hunt all over the place for the flow switch, and it's way up in the piping someplace.
That's where they can get their 3 times their pipe diameter, you know.
Exactly, that's where the long run is, so. I'm gonna go grab a glass of water.
Oh my god.
What?
It says right here.
Yeah, I'm sure. All pies are healthy.
Yeah.
Keto.
Vitamin pie.
Martial art.
How's it going, Joe?
Good, are you?
Not too bad, man.
Good. Hey, are you going to the LG advanced class?
No, because it conflicts with class week.
Oh, really?
Good. Yeah. Yeah, I gotta miss.
That is way too long.
There's like 2 things that my school week does, and that's one of them.
I only go because my short bus has already got me that way, so.
I would go, there's no way to get from DuPont to Bellevue
Yeah.
between 2:30 and 3.
Yeah, that's kind of a bummer.
What is this from?
Yeah.
Oh my God.
That's a high speed,
Did you text
Looking like an older today. Got your fluorescent on.
Yeah, I don't know why I wear it, doesn't keep me warm.
Classes in my
Layers.
house. Yeah, we can do that.
Freezing cold
So is
this
that,
morning.
because do they do that so there's no slipping, there's no slop? Yeah, it's like 5 blows.
so when you buy your gear sets, these are all, depending on the manufacturer, they're all designed gear sets with tip speed on the impeller. So this, and then you bolt it.
That should already be pretty much already.
Oh, yeah, that's all. That's, it's rare to see that
Just
stuff.
plug and play.
Yep, exactly. Oh, yeah.
That doesn't really.
She can straighten your glasses, true me out.
Have you ever?
No, your eye, it's like your eye, like, I keep double taking. One look. It's like when no one lets me know. Yeah, it's been like ever since like, oh, it's driving me nuts.
Talk about some water cool?
Kinda like
That's how
validating.
Yeah, man.
youngsters wear your hats these days.
It's all new to me.
Like she's got those bedazzled jeans on. It's something that only youngsters wear.
That ran truly.
You can jump that.
Jump it.
Sounds like you can jump it. You go first.
I got plenty of scars for that.
That's also.
You didn't make it.
Oh my god. The funniest thing to me.
Against a metal.
No, dude, the funniest one to me, so what that I heard about him, is when he was testing a contactor with his field piece, and he saw his little K-type freaking B probe plugged into it.
Oh,
And his B probe was touching him, and he tested bolted it, boom, knocked it.
This is awesome.
Oh, God.
Yeah, we do lots of classes down there. We got some avions, some refrigerant.
Which one?
Covers just
Sig Data 5.
We have automatic classes coming up. We got that compressor tear down. Basically.
That's probably what's asking, that's why your back's hurt. For rocks or whatever.
No, we just did in the fall, we did.
We have
Maybe, focus on is.
And the refrigerator is big ones.
Oh, okay.
Yeah.
I've never heard that, I don't know.
Most of the time, they're upstairs.
Yeah.
You know,
I had a cardboard, I moved my desk because that, so I held business cards and I got some.
They're trying to prevent it.
What's next to me now?
Well, I had so many people texting me,
Yeah.
hey, I can see you on the camera. So I was like, I'm gonna move back a row.
Great, I've been picking my nose the whole time.
Yeah, that's how I was like really conscious of what I was doing.
I wonder why you look so nervous.
Well, that's why I kept looking up there, and if you look at that thing, it like looks away from you.
Which one's the camera?
Yeah.
Or send.
Are you still looking for like your regular super D, pool? I mean, the application is like comfort cool, like we're doing, it's just like any other system.
You're looking at approach temperature.
And that's what I was gonna ask about too, approach.
Yeah.
How do you determine approach?
Pardon me?
How do you determine approach?
How do you determine approach? Well, you look at, your leaving chill water system, or your leaving chill water temperature, and your saturated, section
We're not
temperature.
gonna do it here, there is a class that's going on up in Highline.
So on a flooded system like that, you want around a 2-degree approach on the evaporator.
Yeah, there's a lot of
And
stuff.
on an air-cooled chiller, because they use, expansion valves, you want probably 5 or 6 degrees.
So you wanna have good equipment and you're checking the temperature. 2 degrees and it's okay.
That's within the margin of error of all the crap that I tend to carry.
Typically, they
Yeah.
do it internally.
Just to remind you that all things are equal. So air, the air, moisture, air comes out, when you want to equal it, it's always gonna cross. But then everything's on that.
That's a good way to put it.
Yeah.
I always get it.
Yeah.
What side was that?
This one's your turn.
No.
Wheatstone Bridge,
Like the,
picture a baseball diamond. Good luck. Yeah, I don't know, I can't explain
Where's
Wheatstone
Doug?
Bridge.
Is Doug on this thing?
No, Doug's not on this thing.
Oh, man, he's 7+ days ahead.
No, I don't know why.
No. Like,
Normally he's
long-
talking by now.
Well, about 2 years.
Playing guitar.
Guy named Doug.
Pla-
Let's see.
Remember you playing guitar that one time?
Oh,
Yeah,
yes.
that's funny.
Yes, I remember.
Oh, you
Like
did?
the whole time?
Okay.
No, he was,
Yeah, it was a city.
he was chiming in on the speakers,
He was
which,
doing
I don't,
something.
hey Travis, why don't you, unmute and say hi to the group here?
He was like super into it.
can hear us.
Can't, not watching.
Pulling shit out of the air. And he's like, and the triax.
Sounds
good. I test triax.
Yeah, I'm with you, Joe.
How do you test triax? Oh, how do you?
With a triac tester.
Calm down.
Or right here.
Well, low.
Did you read the tip of the?
That's what made me think of it.
No, yeah.
Doug and then that.
Zach, did we get a new whatever?
New red and white?
It's already been solved. It was solved by our dispatcher first.
Really?
Yeah.
Yes.
Yeah. Should make everybody feel pretty good.
I haven't even read it yet.
In the back.
Oh, it's like 2.
On what? Alright.
It's Canadian, whatever it is.
Hey, keep it strict and professional. Don't talk about things outside. Wait,
Okay.
What'd you work on today, Chris?
Today, I was at, TCLS Red.
Oh, right on.
Well, it looks like most everybody's back. What do you think, Randy?
I'm ready. Yep.
I filmed for like 2 minutes. That's what I was doing to make crow.
So we're gonna, get into a little bit on, water-cooled chillers instead of air-cooled, where, it's water-cooled, and so they're basically pumping water. Instead of air, you're pumping water through another heat exchanger to condense the refrigerant, and you're moving the heat usually up into a cooling tower. Sometimes they use ground loops, but that's EPA, they frown on that, and that technology's going away, so it's mostly cooling towers now. But this is what a typical water-cooled centrifugal chiller looks like. This is a carrier. You can always tell the difference between the evaporator and the condenser on these because the evaporator is always insulated and the condenser is rarely insulated. Also, the big pipe here, that's your suction line. You can't see the discharge line, but the suction line is always bigger as in anything else, and it's always insulated. These use, that's called a PRV, P rotation vane assembly, and what they do, it's just vanes that open and close to modulate the amount of refrigerant going through the compressor. That's how they control the load. As you can see, it's got all the same components as anything else. It's got the compressor, it's got the condenser, the metering device, the evaporator. It's just a lot bigger. And the problem with these, if you make a mistake on them, it's usually pretty expensive. And all of us have, you know, we've made mistakes on them, working on them, but you just try to minimize it and learn as you go. So typically, you're looking for condensing water temperature in this, in at 75 and out at 85 at 100% degrees. And if your water temperature gets too high, you're going to end up, on your condensing water, you're going to end up putting that machine into a surge. Like Seth said earlier, when these things are in a surge, you can really tell because trains sound like a herd of elephants running at you, and sometimes it's quite frightening to listen to because you think you're just tearing the equipment up. And if you let it surge long enough, you will tear the equipment up. It'll get hot, and every surge you're working your thrust bearings on your impellers, and so, you know, it's important to maintain these to keep them out of a surge. This is your typical chill water system, water to water. You got your chill water loop, which comes in, it rejects the heat, goes out, picks up the heat in the AHU, it's pumped back up through. And on your condenser, it comes out of your pump, through the condenser, back out, and through the cooling tower where the heat is rejected through evaporation. The less humidity you have, the more efficient the cooling towers are.
Hey Randy, how are you supposed to stop it from surging?
Well, so if you walk into a machine room and the chiller's surging, a couple things you want to look at is, number one, what's your condensing water temperature? Usually these are going to be running around 75 or less on an inlet, and on the outlet, if it's running full load, 10 degrees above whatever the inlet is. That's standard, pretty standard design on all of these. If you're running around 85 or 90 on the inlet, that's so high you're going to generate a lot of a higher discharge pressure, which is going to cause it to go into a surge. That's one thing. If you've got low condensing water flow, you're not rejecting any heat, that's going to make it go into a surge. If your tubes are fouled, if you haven't cleaned the tubes, you're not rejecting heat, that's going to cause it to go into surge. If you've got air on the refrigerant side in a low pressure machine, and it's sucked air into it, it all ends up in the condenser, you're running with elevated discharge pressures, that's going to make it go into a surge. So you can tell, for instance, you walk in, it's a low pressure machine and it's surging. Check your condensing water temperature. If it's where it should be, check your condensed liquid temperature coming out of the bottom of the condenser. If its saturated point is equal to the leaving chill or leaving condensing water temperature, you know that you're getting proper heat exchange. And then you take your saturated temperature pressure on the discharge side, and if that's elevated, you got air in the machine. Whereas if you're running with a 85-degree leaving condenser temperature and your liquid temperature is at 95, you got foul tubes. Normally we want an approach on a condenser, and the approach would be your condensed pressure temperature versus your leaving condensing water. You want it to be about 2 to 3 degrees. If you're up around 9 or 10 degrees, you know you got foul tubes. And again, this is almost the same picture as the air-cooled, but instead of the chiller being up on the roof or on the side of the building, it's in a mechanical space down in the basement. You see we got 2 sets of pumps. One of them is the condensed water pumps, pumping the water through the condenser back up through the cooling tower. The other one is a chill water pump, pumping it through the chiller up to the different air handlers you have in the building. So a 4-pipe distribution system, you got your chiller, you got your boiler. Each air handler's got its own chill water coil, it's got its own hot water coil. And they're each controlled by 2-way, 3-way valves, whatever. This is a pretty standard system. On cheaper systems, we don't have it, but on cheaper systems, they'll go with the 2-pipe system or a 3-pipe system where they'll have the chill water going through a coil, and then because they don't have a hot water coil, they just switch over a valve, and instead of the chill water, it's now putting hot water into it. The problem with that is, if, say for instance, they want to swap over from heating to cooling relatively quickly, they're going to run all that hot water down into the chiller, which is going to raise the system pressure, refrigerant pressure on the chillers. And on a low pressure system, it'll raise it above 15 psi, which is what the bursting pressure is on the relief valve on these things. So, you know, it's you don't see a lot of these systems around, but it is something to be aware of. Normally, they'll have a time delay between swap over, like 4 hours to allow the heat to get ejected out of the water. Another problem they have with that is the chemistry is different on hot water versus cold water, and you end up with all kinds of chemical issues, acids and such in your chill water piping. This is a typical machine room. You see we got what, it's like we got 4 chillers in here.
Is that Lincoln Square expansion?
So what pipe, are these chill water or are they condensing water pipes?
Chilled water.
That's right. Why do you know that?
Because it's insulated.
That's right, they're insulated. Normally when they build up a new building, this is exactly how they'll put them in. They'll just line them up and they'll run, these are all in series, or excuse me, in parallel. And again, just like on the air-cooled, they'll have isolation valves, and as the different tonnage is required, they'll open up the valves, and they'll, if it's a 2 pipes, or excuse me, if it's a primary, secondary loop, they'll turn on the associated pump for each chiller. So this is at Children's Hospital. They've got 9 chillers there. All of them are McQuay's, with the exception of the multi-stacks. What we're looking at is the end of the condenser. You can tell because it's uninsulated. And then on the right, that's the chill water side. This is about probably a 400-ton chiller. It's really important to doing your annual maintenances to brush these tubes. We've got some pictures of Grayson brushing the tubes later on in here, but this is pretty standard though. This head here, this is called the marine box because it's a box that's put away from the condenser, and the chill water, or the condensed water comes to the side, you can pull this head off to, whoop. Did it again, sorry. You can pull that head off to brush your tubes.
Because the marine side is where the pipes come out of the chiller barrel, and on the other side is just an end bell.
Yeah, the other side's just an end bell, exactly.
So it's hard to move all the pipes out of the way, obviously, so you can't clean on the place where there's no pipes, then the marine box is how you do it.
Exactly, exactly. If it's, if you're pulling the head off where the pipes are, it's a long reach to get to the tubes though. So keep that in mind if you're ever brushing tubes. This is another chiller at Children's Hospital. This is a 500 ton. And you can see the evaporator is up high by the insulated piping and the insulated shell. And then the condensers down low. And that does not have a marine box on it. You see the pipe goes right into the end of the machine. You know, it's weird. These machines are in the same mechanical space. And they got half of them with marine boxes and half of them without. So I have no idea why they did that. This is that same machine. You can see it's a twin compressor with a common refrigerant circuit. You got these are the oil sumps for each compressor. These are the control packages. Each compressor's got its own control packages, but it works off of one common control panel. This is another McQuay at Children's Hospital. It's got one compressor on it. And this is 134A, so it's got relief piping on it. The interesting difference between a high pressure machine and a low pressure machine is on a low pressure machine, you can actually cut into the shell, you can do work on the shell, you can add stuff to it, weld on it, whatever. You don't have to have it recertified because it's certified at 15 PSI. On a high pressure machine, whether it be 134A, 407C, or 22, you can't do anything on that shell. You can't cut a hole in it or anything without having it recertified. So, and you have to have certified welders to work on them. So that's the main difference as far as.
Does the manufacturer recertify it?
No, you can get it certified locally.
Oh, okay.
But you also need permits and all that. So you got to be real cautious if you're doing any work on these. Some places require these relief valves here. They want them changed every 5 years, or at least tested. I've never been a big fan of testing a relief valve because they tend not to reseat the way you'd like them to when it's done. So it's best and cheapest just to replace the relief valves. And normally when we're replacing relief valves, we buy them from the manufacturer. This is your standard train. Looks like it's a three-stage, three impellers on it. You can tell by there's one, there's two, and there's 3 sections. Each section has its own impeller. Train uses a multi-stage compressor just because they're running direct drive, 3,600 RPM, so they can get the same tonnage out by running more impellers. On McQuay, Carrier, and Yorks, they all use a speed increaser. It's called a transmission to get the impeller speed up so they can generate the tonnage they need out of it. The advantage of the train is they're very quiet. You can walk in and you can actually be fooled because of the pump noises. You can't tell which machine's running. So I've embarrassed myself on that more than once. This is your oil sump here. You can see it's got the oil filter, it's got the sight glasses. Right in here is all the terminals and for your oil pump, and also that's where your sump heater goes. The sump heater on these, you don't have to get into the oil system. It just goes into a well. It's about that long. You just unscrew it, and pull it out. And they do fail about every 10 years or so. You have to replace one. Now this is a low pressure machine. You can see they've got it's called a pressure pack. So when this machine is off, when it shuts off, if they didn't have the pressure pack, it would be sitting in a vacuum. 70 degrees with R123 is about an 8 to 10 inch vacuum. So if you got a leak in it, it's going to fill up with air. The advantage of the pressure pack is when it shuts off, it brings the heaters on, and it'll bring it up to 0 psi. So even if you do have a leak, it's not going to pull full of air. And then when you want to go in and do a maintenance, you can hit a switch and it'll pressurize it up to 5 psi, so you can go through and do your leak check on it. If you're ever doing a leak check on one of these, on a low pressure machine, it's best, instead of going through, if it doesn't have a pressure pack, it's best just to go through and check your saturated temperatures. Take your chill water and condensing temperature. If it's been sitting idle for a period of time, they'll both be the same. And you take your saturated pressure temperature, and it should be real close to what your chill water temperatures are. If you come in and say you've got 70 degree or 75 degree water and you're sitting at atmospheric pressure, you know, and if you use your pressure temperature chart, that'll tell you with 123 you're at about 85 degrees. It'll tell you, I got a lot of air in this machine, I need to leak check it. That's how we, you know, it's a really competitive market out there for maintenance. So on these low pressure machines now, we're going and saying, we'll check saturation. On the trains, you can look at purge counts. They have a purge on it to get the air out of the machine. And it keeps track of how many times it's vented into the atmosphere that year. And if you've been maintaining this equipment for a period of time, you should be writing down the purge counts every time you go in. And if you notice an elevated purge count, you know, it's venting refrigerant out of venting air out of the machine. And we're back to McQuay's. Again, this is an old two compressor system, common refrigerant loop. These are high-speed machines. They've got a speed increaser on them. They whine. They're quite loud, and they hold a lot of oil and they rust a lot.
How come they rust?
Just on the McQuay's especially, they put a lot of liquid refrigerant into the motors for cooling, and if you're running and you measure your motor shell temperature, it's running about 45 degrees, and it's insulated, but so these machines are all pretty old, and the insulation's gotten hard, flaked off, and they start to rust. So that's the biggest issue we have. This dryer here, well, I re-insulated it, but it's a big, I think it's 2.5 inch vapor dryer off the motor. It had actually rusted through to where I was picking up leaks on top of the dryer. So I was after the customer for 3 years to replace that, until finally his refrigerant monitor went off. And it's because it was leaking out of that. I had another McQuay at Benaroya Music Hall that, you know, we maintained it for years, and their refrigerant monitor wasn't working. You know, we kept saying, you gotta get that fixed, and they never did. Well, one spring I went in to start the machine up, and it had no refrigerant at all. It leaked out over the year. And it's 2,500 pounds of refrigerant.
Oh, God.
You know, had they had their monitor working, because it's in the basement, and there's only one exit out of that room, which is where the monitor was, it wasn't working, they would have found that leak, or they would have found, hey, we've got a refrigerant leak. And it ended up on the isolation valve for the suction line. You know, it's a 14-inch valve, and the rubber had split, and it started spewing it out. I don't know when it split, but we do our leak checks in the spring, and so it was during the run time at some point.
Well, how did they get away with that? I mean, because isn't that a fire and life safety? I mean, you know, it's life safety, right?
Yeah. Oh yeah. Well,
because
you know,
you're talking about a basement, and
right.
you know you're air freeing it every time you go in it.
Well, you know, the only time they check it is, when they build the building and the inspector comes through and he's checking everything. Yeah, you got your monitor, you got this and that, you
The
got that.
insurance company,
It's
generally,
It's the customer's responsibility and our responsibility ultimately to tell the customer, hey, this is an issue. And we noted it. I mean, we covered ourselves. We noted it every time I went in there. I put on my paperwork, monitor not working. And we send multiple quotes and they just ignored it until they lost 2,500 pounds of gas.
How much did that cost them?
Well, 134A fortunately is not that expensive. I think it was $10 a pound. And so do the math, whatever that
Oh,
is.
okay.
Yeah, you know, but then there again, it's in the basement and it's all 125-pound jugs. So you know you're wheeling down what 20 bottles of refrigerant or 15, whatever it is.
Times.
And it's labor intensive for sure. And then, of course, you gotta fix the leak, pressurize it, fix the leak, do all that stuff. So, yeah, it's kind of a big deal. So we'll get it in the monitors in a little bit, but that's one big issue that you find is customers do ignore the monitors. Once it's on there, you know, and they require a lot of maintenance, and customers don't wanna pay the money to fix them. So, compressor types. On a centrifugal, it's large tonnage. Centrifugal, stock centrifugals can go all the way up to, you know, just a regular chiller like that. They can go all the way up to 2,500 tons. And that's just for one that you can, if you will, buy off the shelf. And they'll go down to, I think the smallest one they have out now is about 175 tons. This is the smallest centrifugal they have. Very energy efficient. Most manufacturers now are boasting their 0.50 kW per ton, where, you know, back in when I started, 0.1 or 1.0 kW per ton was the standard. So they've cut their operating costs in half on these. And it's all about maintenance efficiency. They've changed the design of the tubes on the evaporator and the condenser. It's all about heat exchange, so they've put rifling in the tubes to get the water to swirl for more surface area. They thin the outside of the tubes for more surface area, and they put drives on them now, and they've made them very complicated. But centrifugals are pretty low maintenance. As long as you do an annual maintenance on them and maintain them, they don't need to be overhauled often. Most overhauls are because customer or service people, whoever, have not done their job maintaining it. The best thing you can do for your centrifugals is keep your condensers clean. If you can reject the heat, they're gonna run. They are serviceable. You know, most 134A machines have got isolation valves, so instead of having to pull the gas out, you can move your refrigerant to the condenser, or you can move it to the evaporator. So that makes it pretty nice. The Carriers, the McQuays, the Yorks, they all have transmissions, so they all have a certain high-pitched whistle that if you're in a loud room for a long period of time, you really should wear some hearing protection. I always did, even back then, and you know, fortunately I don't have any hearing loss, so that's a good thing. Yeah.
When you say transmissions, how much difference in speed, or how many steps are there to the transmission like?
Well, it's just you got a pinion gear which comes off your a bull gear which comes off your motor. These motors all turn at 3,600 RPM, and then depending on the machine and the impeller size and this and that, it goes to a pinion gear. And like they designed the gear code, it's called, depending on what your pressures are going to be, what your design flow rates are. Or what your tonnage is even. They can, like York, for instance, they've got one compressor that'll do multiple tonnages. Just depends on the gear code they put in. Usually the impellers on a York, I'm saying York because I'm more familiar with them, typically the impellers are gonna turn around 8 to 9,000 RPM. So it'll go from 3,600 to 8, 9, 10,000 RPM. On these, we do yearly oil samples, and we send those out for analysis. What we're looking for is moisture, that's a big one, and acid. And then, you know, they throw in iron and aluminum and copper and all that, but a lot of that is all based on what your moisture is. That's what'll screw you up. So this is Grayson over here. This is the job that we did the end of last year at the Arnold building at Swedish. They wanted us to come in and do an open inspect on the and a seal on their chiller. So we separated that's your impeller right there. We separated split the compressor and took a run out and a thrust reading and all that for them. Put it back together. That really didn't take long. It's a low pressure machine, so we pulled the gas out, and it took about a week to reseal it and put it all back together, get it running right. So, but you know, I say it didn't take long, but you know, in your world where you're working on air-to-air systems, working a week on something is a long period of time. But that's the advantage of working on these big chillers. You know, it's not uncommon to work on a job for a week or 2 weeks, depending on what you're doing. So, but like I said earlier, you know, if you make a mistake, it's usually a big mistake. That impeller is probably $20,000. So if you pull it out, and it goes into a seal, so you got to be real cautious. There's like 5,000 clearance. So if you bang that seal up, the seal itself is probably $1,200. You bang the seal up or you bang the impeller up, you just cost a lot of money. So you just got to be very careful. You got to know how to rig. So this is at the University of Washington Bothell campus. This is a York screw machine. You can see that this screw compressor is encapsulated in insulation. That's sound barrier insulation. It's a heavy kind of leaded insulation. It's just to keep the sound down. Because in a mechanical room that is basically enclosed, not really designed for quiet, the noise will bounce around, and these are really loud, so you really got to wear some hearing protection. As you can see, the Yorks have they're an open drive, so they have a shaft seal in here. We were talking earlier about some oil seals or some seals that rely on a certain amount of leakage for cooling and lubrication. Yorks all have a catch bottle underneath the shaft seal to catch the oil, and the oil is kind of important. It cools the machine off and it lubricates it. So we monitor the amount of oil that's actually spilling into that machine. If you're dumping, if you're filling that bottle up, and it's about a 1 quart bottle. If you're filling it up once a month, you got a bad shaft seal. If it takes you all summer to fill it up, that's not a big deal. Just want to make sure you empty it because it will overflow, and it creates quite a mess. So the screw compressors, again, they're very loud. We take oil samples on these annually, and we send this out as well. We're looking for the same thing. We're looking for moisture, acid, and on these we're also looking at the metal content, because when a screw starts to fail, it'll start to put a lot of iron in the oil. They are efficient. They will unload down to 10% of capacity. Biggest problem is because, like I said, with a screw machine, you've got opposing helical screws, and they inject oil directly into the helical screws to create this seal between high side and low side. So if you get a leak, it's going to squirt oil out, or you're going to have a big puddle of oil laying around underneath it. So that's a problem.
What do you do if you have metal in your oil when it comes back?
Well, this machine here, for instance, I've had bad oil samples on this thing for probably 15 years. Every time it's high elevated iron. And you know, at first I said, oh man, this could be a big problem. Let's change the oil, you know, and we'll keep an eye on it. Next year, same thing. And So they said, well, give us a quote for a new compressor. It was like $70,000. I said, okay, well, you know, they are available, so they've also got 2 other chillers sitting next to it. So I said, well, you know, let's just monitor it. Because bottom line is, we're not gonna rebuild this, they just want us to come in and put a new compressor on. I said, so if it fails, it fails. Well, here we are 15 years later, the same still runs, we still get elevated iron content every year, but it's still running, it still sounds like a screw machine, so, you know, I guess we're lucky on that one. But yeah, if you got elevated iron, it's typically coming out of the compressor. And if you're lucky, it's not a big deal. If you're unlucky, the thing will, usually it seizes up on, because it's very tight tolerances in there. At that screw class you're gonna have, you'll be able to look in and see the thrusts on it and how tight everything is. And so I'd like to go to that. It's really gonna be an interesting class. So at York, they never allowed us to rebuild their fricks. They bought frick compressors, and they wouldn't allow us to rebuild them. They said just come in and replace the compressor. So we never really learned much about rebuilding screws. So this is your typical oil sample that we get back when we send it out. You can see it's got the acid numbers, it's got the water content, right in this area right here. This is what we're looking at. This is a big one. This machine here, this has been a Royal Hall. 244 parts per million, and the acceptable range is less than 400 parts per million. So that's great, you know. And then down here, you can see it's got all the dates. So this company actually tracks everything, and you can show your customer, well, yeah, you know, it's tracking pretty good. Nothing really changes much. You can see when we went way up on parts per million right here. That was the year they lost all their refrigerant. So I was really, when I first found that, I was really concerned that they broke a tube. That was a big problem, but it wasn't. So the annual oil samples, it compares the last to current. Again, you're looking for changes, metals, moistures, and acids. So it's a great tool. Some people say, oh, you don't need that, you're wasting your time. But it is a great tool. If you get elevated water, you know you got problems, and you really need to address that situation. If nothing else, change your dryers and change your oil.
What's your limit for water on like the screws for parts per million?
Well, they're all the same, you know, it's all, we'll go back to that. It's all, crap.
You have to be real anal about taking your samples too, and making sure that you dry the refrigerant out of there. You're not taking them on a humid day, and that you're getting them back to the shop and getting them sent out immediately. You know, don't let them hang around in your van for a day or two, because even when you take them and you get them to the shop, it takes almost a week before they actually sample those. And and generally when you get a high one, you know, a lot of times it's cheaper to take another sample to make sure, you know, that you actually got a true high sample, that you didn't screw it up or the lab didn't. We used to have Herget used to do it before, and they were terrible, because if you actually looked at the samples and when they actually did it, shit, sometimes it wasn't, you know, 2 weeks, 2.5 weeks before they'd actually sample it, and you know, magically they'd always be high then too.
Right. There are certain ways you got to take oil samples. Low pressure ones are nice because, you know, you don't get the foaming, but you get into R22 or some of the higher pressures, when you take your oil sample, you get a lot of refrigerant mixed in there, and if you take your oil sample, seal it up, put it in your van, it's hot. I've ruptured a few bottles that way. So the way you're supposed to do it, which is, you know, it's very costly to do it this way, but they actually want you to remove the refrigerant from the compressor, take your oil sample, and then put the refrigerant back in. And you know, it's unrealistic. It really is. So you just got to be really careful. And like you said, you got to be quick when you pull the oil out. You don't want to just set it over here and leave the cap on, because POE oil especially is very absorbent of moisture.
And
so
most all the screw compressors have POE in it. They don't have mineral oil in it. They got POE. So
most of them have POE. You know, So the old, when York first came out with their screw machines, they were using R22 and mineral oil. And the biggest problem they had was the oil would foam out and you lose all your oil in the system. You know, we're talking 15 gallons of oil. And it would foam out and go on the secondary oil return pan. And so they actually swapped the POE oil on that as well. So they all use POE now because it's more stable. But like I said, it's real susceptible to moisture, so just want to make sure that you seal it up.
A lot of times, if you're looking at your, I always used to watch the iron count too. You talked about where, you had where, like, you had one that, the iron came up and, you didn't, I don't know if you, I don't know on yours, but on mine, I noticed that, if my iron count get up, then I generally needed to really look and see, make sure that my metering devices, that I wasn't bringing any liquid back.
Right.
Under all conditions, not just the condition we were out there on the perfect day. And
Right.
most of the time, and there's a fine balance between getting it to where, you're not bringing any liquid back, but you can't have too much either, because then you have high discharge temps.
Well, most of these compressors nowadays are protected. They look at superheat, and if their superheat drops, it shuts them off because it's moving too much liquid through.
On the chillers, yeah.
On the chillers, yeah.
I've only dealt with them on, like, mammoth units and,
Right.
And.
Right, and these are all flooded systems and all that, so you need to be really overcharged to be bringing back a lot of refrigerant. But yeah, so if your superheat drops on this rapidly, or it's running below where it should be about a 30-degree superheat, if it's running about 10 degrees, it'll shut it off on low discharge superheat, and it'll say high refrigerant charge. So this is a standard oil element, and filter dryer. This is a spin-on. It's a lot of them are that way. Yorks are elements. So you actually pull the canister off and drop it in. But this is something that we recommend doing every year. It's changing these dryers and changing these oil filters. It's that's how you're going to increase the longevity of your equipment. On low pressure machines using mineral oil, I recommend changing the oil every year. Mineral oil, the oil sump, oil heaters break down the oil, and you end up with black carbonized oil. And even though you send your oil sample out and it comes back all okay, change oil is cheap insurance.
Is it also just because it seems like with those low pressure machines, you're getting moisture in the system one way or another?
Right.
So you just.
Yeah, and the moisture breaks it down as well. So, yeah, I've got machines I've taken care of for 30 years, and I change oil every year, and we've never had an issue. And the oil comes out clean every time, but I take an oil sample, and I also change oil.
But they really design it to where the oil heater breaks it down, because I know they say don't let it get into the 200-degree plus range for too long, but they really design it to where.
Well, the oil, it's. So on the Yorks, well, even the trains, that element gets hot.
Yeah.
And yeah, you want your maintaining oil about 140 degrees.
Yeah.
But that oil around the element, it's who knows how hot it is. But it breaks it down, and you end up with really hard, chunky carbon deposits on that thing. And it bypasses your oil filter somehow. It'll end up in these aluminum sleeve bearings, and it'll just wipe them right out.
So when you do that, you'll just pump it down, replace those line dryers, change your oil, and that's kind of considered regular maintenance.
And mineral oil's cheap.
Yeah,
so
that's cool.
Another thing we do on all our maintenances is on all the centrifugals we don't do it on screws because there's too much vibration involved, but vibration analysis. And we have the tool, it's an augury, and you guys should be using it on air handlers too. It's available to everybody in the company. And it's a great tool, and customers love it, and it gets us in the door, and we just include this in all our maintenance. For me, I don't know if it's, I honestly don't know what good it does for you, but customers like it, and
You haven't seen it, what you're saying is you haven't seen it as a very good diagnostic tool to tell you whether your bearings are actually going and stuff, or I mean,
if you do it enough, you can see differences, but the vibration is gonna change depending on water temperatures, on loads, on everything. It's not gonna be the same. So so we take well, Boeing Kent's a great example. They thought they had, well, they got a bad motor. The motor, it's a 1,000 horsepower motor, and it's getting hot. So we said, we'll do a vibration analysis on it and see if we can pick up some harmonics or something. Well, it came back, it had bad motor bearing. Well, I had just replaced the motor bearing, and I know the motor bearings weren't bad. But, but it got us in the door, and the customer liked it, and it's all good, so.
I was just kinda curious, I haven't ever used the augury tool, but I mean, I've used BSC before on some of the big mammoth units that, have big supply fans and stuff like that. And,
Well, I think it's got a great place
particularly
for balancing, for monitoring your air handlers and all that.
Replace the bearing or whatever.
Or misalignments, or.
And then doing the balance test afterwards, and, we fine tuned it, and, prevented,
Right.
prevented, another bearing failure.
Right, yeah, and that's.
I mean, I found stuff where,
Yeah.
it's prolonged the life of the equipment,
Right.
had I not done it, but I wasn't smart enough to.
So this is an example of a recip water chiller. You don't see a lot of these out there anymore. This is a McQuay. It's got two Copeland recips on them. And I do have to say they were pretty reliable. This machine was put in probably in the mid-'80s, and I just replaced the last compressor on it last year. So that's a lot of years to have the original compressor on it. And, recips are pretty high maintenance, they're inefficient, they're also obsolete, you don't see them around anymore. They're somewhat quiet, and we do oil samples on site with the Sporlan test all. One thing I didn't mention, depending on the size of the machine, like if you got scroll machines, number one, they don't give you an oil access. So what you can use is, I forget what it's called, but you just put it on the suction line and take a burp of gas out, and it'll tell you what your acid content is on that. The recip maintenance, you do your operationals, check superheats, all that stuff, oil levels, on-site oil sampling, you make your motor windings, and your visual inspection for refrigerant leaks and all that. It's pretty simple stuff. We're getting back into turbo cores because they're on water cooled, more water cooled than air cooled actually. And these are the multi-stacks I was talking about at Children's.
How much do you love those?
Hmm?
How much do you love multi-stack chillers?
Well, I don't like their Corel controls. I don't like their raised plate heat exchangers. I don't like their price. I think I've heard they're about $50,000 a piece per module. This is a 6-module chiller. It's all got the turbo cores on it. That's an option you can have. A lot of them have, Copeland scrolls on them, I think. And they'll have three scroll. They're 50 tons a piece, so whatever the equation is, I think it's 3 17-ton scrolls on them or something. I think they're overpriced, and they've got an application, but no, not much in my world. Hopefully I don't have a multi-stack guy. Who is it, Jim Black or?
Well, Jim Barrett was, well, you're talking Keith Black.
Keith Black,
You
yeah.
just mixed up two different technicians.
Yeah, get them all together.
Because Jim did some turbo core work too, but yeah, Keith worked for multi-stack, and that's what he did was, he was, but I don't know that he was specific just to turbo core, but he was multi-stack.
Multi-stack, yeah, and he traveled the world, and I'm looking, these things are super simple. Why do you need a guy traveling the world to work on that? It's like, you got your Thermal King technician that's traveling all over the world to fix a truck cooler. So, but is Keith still working for them?
He's over at Hermanson.
Oh, you went to Hermanson. Yeah. Well, there you go. So, maintenance, we already went over that. There's really not much you can do on them. You need a special tool to plug in and check everything. Todd Zeller's qualified, Jeff Rosso's qualified. These are chiller guys that we have within us. You know, if you guys are ever out in the field and you get a chiller call, which you might, the chiller team is only on call in the summer. Wintertime, we're not on call, there's not many of them running. But you can call any one of us on the chiller team, and we'll answer your questions. We're all working for the same team, and we will answer your questions, and we'll help walk you through it, you know. And there's only gonna be a certain amount of stuff you guys can do, and that would be, you know, check flows, check this, check that, and that's about it. Anything else is... So this is a water chiller with scrolls. You don't see this very often. This thing looks like it's 1,000 years old, but low tonnage, you can stage them on, pretty efficient. And again, you only do oil samples if you suspect a problem, because there's typically no place to pull the oil out, and if you took an oil sample and sent it out every year, you'd be out of oil pretty soon. You guys work on scrolls a lot anyway, so you know, yeah, you know how they work, you know what they sound like, all that. So on the maintenance, we do an annual leak check on these. You know, on the annuals, so we've been talking about doing the visual. That's when you do an operational. You're going in, you're just checking things out. You don't want to do a leak check every month, but annually, yeah, we go through, we do a leak check on the high pressure systems. This is the only picture set that I can find of a leak detector. It's a good one, but you get the point. So on most control panels nowadays, whether it's Carrier, York, Train, whatever, they all have pretty high-tech control panels, and you can actually go in and hit the history key, which is, oh crap, I did it again. Sorry guys. There it is. It's that button right there. That's your history button. That'll give you the 10 last history shutdowns, and you can also scroll through and see everything that was going on: pressures, temperatures, oil pressures, amperages, everything that was going on at the time of shutdown. So it's a great diagnostic tool. And also it'll tell you what to shut off on. It'll tell you flow switch, it'll tell you overcurrent, it'll tell you high VSD temperature. It tells you everything. So you want to make sure you review the alarms. That's a great tool to you can take back to your customer and say, hey, I've noticed this thing's been going off a lot on low water temperature or whatever, you know, and it's, you can approach them for repairs. You can go through, you calibrate your sensors. Basically just look at your pressures, your temperatures, make sure they all line up and jive. And again, you check electrical connections. You know, you pull the panels open, have a look at everything, just look for obvious burns, heat, things that shouldn't be there.
Can you edit those sensors? So when you're saying calibrate the sensors, you know, you look at your pressure.
You can go in and offset them.
Okay, you just would set and offset. And
yeah, you can go offset them. So if you got one that's running high or running low, you want to make sure you know you did that though, because there's probably something going wrong with that transducer. Because normally they're pretty nuts on. Yeah. So you get one that's drifting, you want to make sure you do it, and then note to yourself you want to go back and look at it again later. And again, it's important. This is probably the biggest thing you can do to keep your chillers going is brush your condenser tubes. You're familiar with that.
Children's.
Yeah, he was helping me one year, and it was quite the deal. 9 chillers, they're all about that size.
That tower was the worst. It was 8 full hours of getting mud out. That one tower.
Yeah.
That was the worst.
Yeah, they've got cooling towers there that it's a brand new cooling tower, and I don't know how many 55-gallon drums we pulled out of there.
It was all day.
Yeah, it was all day. It's a big tower though. It's twice the size of this room the sump is.
Oh my God.
And it's a mess. I had him in there all day doing it. I sat out and received the vacuum cleaner. So. That's what happens when you get to a point where you're going to retire in the next couple of years. Yeah, just sit out here. I'm fine. So, but yeah, clean the condenser tubes by punching it. That tool there, it's called a It's a Remomatic, and it's auto feed. Now, have you guys worked with the Remomatic
I think the
before?
auto feed's slower than manual. I'd rather use manual.
Well, if you're doing a bunch of tubes though, you'll find out. I disagree.
I love using it.
He has strong forearms.
Yeah, I got tendonitis from hand feeding. You do enough, yeah, it wears you down. But so that's got it's got a little gun that you press a button and it feeds the brush in, and the brush is in a tube that squirts water out, so it's flushing it as it's brushing, and then it pulls it back. And so if you're consistent, you can do that in 4 hours. Pretty easy. A lot of this though, the most time spent is isolating and draining. Because, you know, unless you got a compressor down there where you can introduce some pressure and blow it out, you know, it's all gravity. And it's really recommended not leaving the space while you're draining. And it's also recommended not leaving the space while you got your heads off. Because if something happens, like if you go away for the night and come back the next day and discover that somebody swung the valve open or automatic valve open or something, and you flooded the whole building, and that's happened. I saw it happen in a building at Genentech in San Francisco where it wasn't us, but the contractor had left the heads off, and then he didn't isolate anything, didn't lock anything out, and then the valve automatically opened, and it dumped all the water out of the tower into their machine room, which was upstairs. And it drained all the way down. It was like a 6-story building. And when I got there, they had fans down on the first floor because it had flooded everything. It was just a terrible mess.
Is the building down?
It happened downtown 4 years ago. They somebody left it open, and automatic valve open in the middle of the night, dumped it.
Yeah, it happens. It happens
It
more
was a
than you
much taller building.
happens more than you think, you know. So rule of thumb: don't ever leave the head open at night, even if you're not done. Button it up. You don't have to fill it up, but at least put the head on and put a bunch of bolts around and make sure everything's closed. So if something does happen, you know, it's contained. So brushing tubes every year, it will increase the efficiency, heat exchange, and it will extend your chiller life by a long period. Another thing we do, we recommend this every 5 years, is have your tubes eddy currented. Anybody know what an eddy current is? Basically, it's a probe that you feed into your tubes, and the probe introduces a magnetic field around itself, and it looks for, it measures the thickness of the tubes. It locates outside diameter pitting or inside diameter pitting. It'll locate cracks and support wear. We don't do this in-house. There's too much liability. If you miss something and the tube breaks the next week, you don't want to be liable for that. So we subcontract Tubular Technologies. He's a guy that's been around. He's out of Mercer Island, done a lot of them.
What's the percentage of tubes that you can have blocked off, or?
You can have up to 20%. So, you know, and it's one of those things that on a new machine, I like to do just a footprint, have an eddy current, that way you got it on file. 5 years down the road, have an eddy current again, compare it, you know, and then every 5 years after that. And when it gets around 20, you should probably do it every other year. Again, if you break a tube, it's a big deal. It's expensive, and you want to do it. We did, they broke a tube at Group Health up on Capitol Hill. And I got the service call, the machine wouldn't start. They were blowing fuses. So I'd go up and look at it, well, the compressor had seized up. And it was the acid that had been generated by the water in the machine that had it just aided all the aluminum bearings and turned them into this white powder that just seized everything up. So that was a fun job. That was quite the overhaul. Here's an example of a guy.
Not wearing gloves?
Is he? Well, he's a subcontractor. So, but he's doing eddy currents on an evaporator, and it somewhat looks like you're just brushing the tubes. You're just putting the thing in, you're pulling the thing back out. Over here, you can see he's got a scope here, and that looks like.
Front row.
There we go.
Good
Hit,
job.
hit buttons too close together. So, right here, this is what his scope looks like. When it's going up like that, everything's great. He's, you know, when it starts getting a tick that comes off this way or a tick that goes down that way, he can tell if he's got an ID pit, an OD pit. If this starts going elongated like that, he knows he's got probably a crack or something, and he notes it. He also takes a graph of every anomaly that he finds, and then he'll, depending on what he's finding, he'll put corks in the tube with the different colors, and then he'll go back and revisit those. And then the report you get looks like that with all his findings. But right here, there's a crack, stress corrosion crack. That's a freeze burst. Then you got your OD crack or pit. That's support wear. And then your ID through hole. Remember I was talking about the different types of tubes they have? That's the finning that they put on these, it's almost a thread that they put on these copper tubes for more surface area, more heat exchange. And that's the inside of a tube. You can see it's kind of rifled. That's to get the water swirling so it'll get better heat exchange. Brazed plate maintenance, we already talked about this, but take special machine, we've got one, so, and it's in the chiller lockup, if you guys ever get in a situation when you need to use it. Ask Daryl West, or one of those guys, I'm sure he'll lend it out to you.
Yeah, if you remember when we, Alpha Lavelle was here last summer, they brought that trailer, and then they had the plate and frame heat exchangers with all the plates. That's basically what those are, but they're brazed. They put them in a furnace, they get all brazed. But one reason they're so susceptible to damage and freezing is because they're a bunch of plates sandwiched together and brazed around the outside. You can see like the copper color from the brazing. And imagine if that thing's full of water and then you freeze it. I mean, even if it doesn't rupture on the outside, it's just going to push those plates together and just squish them, and then it cracks, and then they're garbage. And if you think about, you know, what's inside that heat exchanger, Dave, you know what's in there?
Inside the heat exchanger?
Yeah. What's inside the heat exchanger there?
Water, right?
Or refrigerant.
Or refrigerant, okay.
Yeah, and so a lot of times if you get a crack, one side's refrigerant, the other side's water.
Oh,
and
they'll
it
mix.
just, yeah, it just mixes. Doesn't take much versus like a shell and tube. I mean, you got those long tubes and surrounded by a giant cast shell. Yeah, you can still crack anything with ice, but it's a lot tougher, a lot more resilient than these things.
Makes a lot more noise when you break a tube versus this. You can hear it pop when you break tubes. It's quite the noise.
Those plates are the same design that with the opposing flow?
They can be,
Each plate's opposing flow, or?
Yeah, each plate is a different, it can be counterflow. Yeah.
How big of a difference does that really make? Because I've come across a lot of hydronic heat pumps where they piped them up wrong. You know, they're supposed to have refrigerant going one way, the water going the other, and I guess the idea is to maximize the heat transfer.
Yeah,
But I've seen there's a handful of them that I got that have been running the same way for a long time, and I'm getting the same readings, you know, off of Climate Master's own specs, like for the water temperature and you know what my split should be, what my pressures are.
They'll run fine at R22. As soon as they switch the heat pump to a 410, it won't work.
Really?
I know from experience.
Wow.
Makes sense, since it's R22.
What's interesting about these is, you know, I've always been on the idea water goes in the bottom and comes out the top. On these, water goes in the top and comes out the bottom. So, but anyways, it takes about 4 hours per unit to clean it, and check approach to confirm if it's clean or dirty. So just like anything else, you know, compare your saturated temperature to your liquid temperature. Again, here's chill water pumps. They're insulated. We were talking about balancing valves. These are your balancing valves here. These are your isolation valves up here. The guy comes in and puts his pressure across here, and looking for flow, and he'll adjust this valve to get the pressure drop he wants. And they go by the impeller curve on that, on design. These are condensing water pumps. How can you tell?
No insulation.
That's right, no insulation. Same thing, you can see it's got the balancing valves. These are identical pumps, the same machine room, just one's insulated, one isn't. Cooling towers. So this is what is called a closed loop cooling tower. You can tell a closed loop cooling tower because it'll have a pump on the side of it, right there. What this does is closed loop. It's got its sump water here. It pumps it up through spray headers, goes across this is your condensing water here, and it's a closed loop. At no point does that water touch the water or the air going through the cooling tower. Advantage of this is you can treat your water. It's a closed loop. You don't even have to clean your condenser tubes or anything, because you can maintain your chemistry. So these coils are expensive. These are expensive towers. Disadvantage: they're not very well. They're efficient, but they're not as efficient as the open loop cooling towers. This is an open loop cooling tower. You can see your chiller's down over here someplace. It pumps it up here through your fill media, back through the airstream, and then back out. Yeah, okay, good. The biggest disadvantage of here is you pick up any dirt that's in the air. It's a great air washer, and all your dirt will end up in your tower, and then it'll ultimately end up at the lowest point, which is in your chiller. So, again, brush those tubes every year. And refrigerant monitors. This is, ironically, this monitor doesn't work. You can see the lights are on, but it's not working. Again, we've quoted it multiple times. This is a children's hospital of all places. And for whatever reason, these guys just don't want to fix this stuff, and it's not very expensive, but whatever. But what a monitor does, it monitors their air quality in parts per million. There's multiple stages you can set your alarms. It's designed to protect people. Notifies you if you got a leak. It does require annual calibration. We do that in-house. The chiller group, we've got all the tools for it. It's a code requirement to install on a new building when the inspector comes in, or any retrofit you're going to be doing on an old building. The inspector is going to be looking for that refrigerant monitor. And it's normally tied in with the building automation system to bring on the exhaust fans and also to send a notification. Usually there's 3 or 4 different levels. The first level of alarm would be this light would flash. Second level would be a notification to the customer, and the third level would be bring on the exhaust fans. And some of them shut the chillers off too. And we've already seen this slide. Standard air handler. So if you got a cooling tower, one thing you do need is your chemical station. And this is a really nice one. It's designed nice. They've got all the nice pumps mounted nicely. They've got this is your sensing station here. They're looking for bio. They're looking for synthetic growth, whatever. And they add chemicals and bleed water appropriately. Again, we don't do this in-house. We recommend Chemtech. But chemical treatment is really important, and it's something you should discuss with your customer, if you're maintaining your chemicals, because it will screw you up. It will cause your machine to run poorly. The University of Washington, Bothell had a chill water leak, and they had it for over 2 years, and they were dumping 20 gallons a minute someplace. And, you know, needless to say, they stopped putting treatment in their chill water system early on. And they spent a lot of time, a lot of money trying to find the leak. Well, over this 2 years, they developed a bacterial growth on the chill water side, which it's just this nasty, rusty looking slime that forms on the tubes and on all the piping. And makes the machine look like it's running low on refrigerant. And so, you know, once they found the leak, they were able to take care of the chemistry and problems all went away. But if you got a customer that's not, you know, doesn't think he needs chemistry or whatever, he's wrong. You got to take care of that. So how do you identify manufacturers based on color? They're all kind of different colors, and they all have their own special colors. So McQuay's are typically gray or brown, and McQuay is now Daikin, but you can see what color it is. York, it's Caribbean blue. Real pretty, reminds me of the Caribbean. Carrier, they're green, either green or they've gotten more to a gray on their newer equipment. And then Train, I think their color is called Executive Brown or Executive Tan. You know, they got all their own weird little names, but they're all different colors. The best way to identify a machine, of course, is to look at the control panel. Usually the name will be right on it, or look at the nameplate. If you work around them enough, you should be able to just walk in the machine room and say, yeah, that's a McQuay, or that's a whatever it is. Again, the control panel nameplate. It's important to know where it's at, and it's important to write all the information down. Nowadays, you just take a picture of it. It takes a few seconds, and you got it on record. But anything you're going to do on this equipment, they're going to ask for model number and serial number. That's number one. And on Yorks, they're going to ask for the gear code. They're going to, you know, it tells you the refrigerant type, the refrigerant charge, your volts, and your amps. I don't know why this is under control panel nameplate, but this is a electromechanical starter, which we've got an example of an electromechanical starter there. It's kind of old school, but you still see it out there. This is part winding start, Y delta. This is a open transition.
If anybody wants to go through this here in a couple minutes, Randy can kind of explain it, or we can talk about it. It's pretty cool how they work.
So when you're doing your visual maintenance on electrical, you want to make sure you look at all of these connections here, anything where the high amperage goes through, the high voltage. And I usually, when it's running, I'll take my laser temperature sensor and I'll measure across the contacts. And it's amazing the things you can find with that. You know, if you're looking at a 5 or 6 degree differential, that's not a big deal. But you get up around, you know, 30, 35, 40 degrees, you need to address that, because if you let it go, you're going to build up more resistance and more heat, and eventually it's going to come back and bite you. Different refrigerants. So we've talked about low pressure, medium pressure, and high pressure. Medium pressure would be 134A, R12. High pressure is 410A. And that's most of what you guys work on these days, I suppose. Not my favorite refrigerant. Low pressure refrigerants, R11, which is an old school refrigerant. 123, which is one of those refrigerants that's on the list, but they're coming up with replacements. And then 113, I don't know if there's any more 113 out there at all. But these are all low pressure. Your machine runs in a vacuum on the low pressure side. So I wrote this down. We did this just so you got an idea of the different freezing points. And the reason why I put freezing points in there is if you're working on a chiller, you need to be aware of where this machine's going to freeze. You're moving refrigerant around. Freezing the machine is the worst thing you could ever do. So if you're ever moving gas and you're trying to evacuate it and you get down below the freezing point, for instance, water boils at 32 water freezes at 32, and water is a good refrigerant. If you ever worked on an absorber, that use water for the refrigerant. But 123, that it boils at 82 degrees at atmospheric pressure, and it freezes at 20 inches. So if you're evacuating a machine and you drop below 20 inches, you want to make sure that either your evaporator's been drained or that you have water flow until you're absolutely sure that all the refrigerant is out of that machine.
So you just never want to isolate it, all that water. You just don't want standing water in there?
You don't want standing water when you're down below freezing. Even when you approach freezing, when you're getting around 34 degrees, which would be probably about 19 inches, you just want to make sure you turn on the chill water pumps and get some kind of a flow. Typically, I wouldn't drain it unless you're planning on popping the head off anyways, because you'll screw up your chemicals. Average operating suction pressure on a 123 chiller is about 17.5 inches, which is 45 degrees. R22 boils at minus 41 degrees at atmospheric pressure. Well, you guys know all this stuff. We did this for the salespeople as well. But again, R22, when you get around 60 psi and you're continuing to pull it down because you don't know if you got all the liquid out or not, just make sure you got water flow. Usually what I'll do if I got time, I'll drop it down to about 32 degrees and I'll let it sit. And I'll watch my pressures go up, and I'll be touching the liquid lines and touching the bottom of the condenser and you know, looking for any metal I can touch on the bottom of the machine to see if I'm freezing or not. But regardless, make sure you got water flow. That's it.
Yeah, that happens on like vertical self-contains once in a while, where you got a water barrel or even that raised plate where a guy will recover the refrigerant out, and he's basically pulling vapor, so it's boiling the refrigerant inside that heat exchanger, and it freezes the water, and then it splits the tubes or pops the heat exchanger. It happens about once a year around here, it seems like.
Yeah.
Somebody's just not running the water.
I've only broken froze one machine. It was a 1,200 ton screw machine. It was one of those places where it was a plant and I had to go to the operating room to tell them to give me water flow. I said I wanted 500 GPM across the evaporator, so he does whatever he does, and we're reading 500 GPM on his meter, so I went back and I pulled the gas out, and towards the end of the day I heard this loud popping noise coming from within the machine. What was that? You know, so I thought, well, it's time to go. Next day I come back in, well, the sight glass on the side of the evaporator is it's full of water. So I went in, isolated everything, drained it, went in and talked to the guy in the operating room, and I checked his flow rates. Even with all the valves isolated, still had 500 GPM. So yeah, it was his problem, which I still felt bad, but I felt a lot better. So, you guys got any questions, or? We're talking about, you know, approach and this and that. One way you can check the refrigerant level in your machine is by approach. On a flooded machine, which is most centrifugals, you want an approach of 0 to 2 degrees. You know, suction evaporator approach. That's your suction pressure compared to your leaving chill water temperature. And your approach on your condenser, which is your discharge pressure versus your leaving water temperature, you want that about 2-3 degrees. So. Well, like I said, you know, if you guys happen to be on a service call and you got questions, it's got a great chiller team. You want to make sure when you walk up to a customer that, you know, you don't look scared. You know, all of us walk up on machines. I've got lots of experience. You go up to a machine and you're baffled and you don't have a clue what's going on. The customer comes up, oh, what's going on? Not a problem. We'll have this running for you shortly. You can still look on it. Inside I'm crapping myself, but you know, you just gotta look confident. gotta show the customer that, yeah, I know what's going on.
Put your head down and walk fast.
It's pretty much it. But, you know, we got the resources here, though. I guess that's where I'm going with this. If you don't know, somebody does. And if we don't know, we've got our resources as well. So most of us on the chiller team, we're all ex-factory guys, Carrier, McQuay, York. So we got our resources. Well, thanks, guys.
All right, thank you.
Hope I didn't bore you too bad.
We do open shops in the back, so we have a workshop back there.
Well, I mean, like, how much am I gonna give you? Saws all over the wood blade, and you're gonna be out there all night?
So you were around for Mac 90.
Do you have your cut-through gloves?
When you start, why don't?
Do you have your safety
So like
glasses?
we
Yeah.
Do you have PPE?
You have proper PPE? This one,
Proper
put together, bring it up to speed. Usually there's a timer or.
Get some more chicken in your bodies?
But once it comes up to speed, chillers will start to dry down.
Playing Call of Duty, kitty.
Yeah, okay, do you wanna be playing Apex Legends?
Once it comes up
Yeah,
to
one
speed,
was a
it'll
waterfall,
transition,
chill water.
This one stays cold.
The other one was had foil.
And then, yeah, they both transition, you know, it's
And we had a bunch.
you know, water, the other
They're just, so you just shoot that, your
First
stickers,
you'll have is cold
Oh,
mold well, it goes to transition, then nobody can put your dead shoulder. And also
chicken,
send
more
power.
chicken as well.
I'm not taking it.
It's all takes it like, and it's very momentary.
Always open.
That was all right.
We're hoping, actually, well, there's a big building out back right now.
This will pull in, is that what you're saying?
Yes.
Now it's part of its fleet, but we're gonna end up taking it over.
This is
And so hopefully we can start more operating more year round and actually be able to, instead of having classes in here.
It's pretty much been replaced by drives.
Yeah, you know,
Have classes,
the
but
problem
then a
is,
giant
it's
workshop.
pretty good technology, there's really not a lot to go wrong
Actually
on
be
it.
around like.
Biggest
their
problem
enter-
is,
big stuff.
these contactors up there, extremely expensive. Can you rebuild those?
So we don't have boilers.
You can rebuild them, yeah, you bet. You can rebuild them, replace the relays, or replace the contacts and all that. But some of these contacts are like $5 grand.
As a company, you don't build.
You know, and then you start looking at, say, a Benshaw drive, or something like that, a soft start, where you can buy that and install it for $7 grand.
We gotta have you brace some pipe up this year. Do something. Yeah. Do something.
When it gets nicer.
Yeah, when it gets nicer. Yeah, absolutely.
Of course, the bigger the
Part winding start.
bigger the motor, the bigger the starter. This is off the guy here, I don't know what.
I did, yes.
how big
I
that
don't know
is,
the-
but I would
You did.
guess
Oh, I didn't
it's
sign it.
probably
So is
Sign
this,
it.
$100
No, yeah,
kind of
is this
chiller.
one assigned by
What
you
do I
guys,
get?
the part one, part two?
Yeah, so these are actually customer university classes out of the Rivian office.
Okay.
These are customer classes, so you'd have to read this whole thing to kind of have that make sense. These are classes that are done for McDonald owner employees.
Oh, okay.
And there's actually, these are more geared towards techs. If you go onto the MacTech site, there's an intro to HVAC. There is this class, but this is about 3 hours and 22. The one that'll be in-
Electronic flow switches?
I kinda like that it's a chip.
April.
I get them from,
What level is it?
here. Well, you know, normally, we don't do this as far as good customers say, hey, you know, let's go ahead and do this, he says, great. I call up Jeff Morash and say, hey, you wanna quote this guy? Okay, great, so he sends him a quote, he locates the stuff.
Okay, so you're going for Jeff to.
Right,
Somebody at your level
right,
works in this
right,
area.
but, you know, the IFM effectors,
Because I got, you know,
Good.
I know that, you know, what I've done is, when I put differential pressure switches, but I didn't think you're looking with those things, you have to do real careful, because they don't really make them down,
Well,
just
they're
down that
5
low.
PSI,
Yeah, I was gonna say, and so, you know, constantly cycle those things every time, just to make sure that they're gonna work, so
IFM effector, you know, Branham Instruments may sell them, I don't know, but,
And then they got another place where, you know, they turn on their chiller based off of, you know, it's like 2 different buildings, and, you know, if I got flow, they'll turn on the pipe in the other building, and then, you're measuring flow over here, and if they got flow, okay, well,
Yeah.
I'll turn on the chiller.
Okay.
And, we've had, troubles, they have one before, that, was different, it was working off different pressure, it was off like a little analog gauge, and when the gauge, went over, and then it switched, but
They'll be in for that.
it wasn't very reliable, same thing,
Same thing, right.
if I could,
Well, talk with, Dave or Steve or one of you guys. Yeah, that's That's what I go through, yeah. Yeah, that's the best way to
You gotta jump.
I seen one before, it wasn't quite like this one here. Once it had like a little wheel on it or something.
Yeah.
Those,
Have you ever done like?
Doubletree Destiny.
Oh, down at,
That's got
Sunset?
that, yeah, the one right across from Sunset.
Right, right.
So you have like,
we had
a
problems.
checklist of different things that.
What's that?
Has there ever been a time? where-
Yeah, well, and it had, it was really.
Those are actually flow monitors, you kind of pass the spin it.
Yeah, and really, that's all it was, we just pulled it out, cleaned it, stuck it back in, and it worked. We had a pretty good, plate on the side of it, that kind of really told you, how fast, and it gave me a signal coming out, so I was like, okay, well.
Yeah, they've got all kinds of weird flow monitors, they got actual bubble flow monitors, count the bubble rate going across your pipe. It's like, really? This works?
I think Custom Balance has got one of those, and we
Yeah.
had one of those Custom Balance guys.
I don't trust those.
Yeah, well, I mean, it helped us figure out that, where, because we knew we weren't getting the flow to our, down to the pumps, we were getting the flow, but we couldn't figure out where we were losing the flow at, so we used it through the building, and we found out what branch was, not flowing, and then, okay, it's that isolation out there, that.
Diagnostic.
Yeah, so,
Alright,
This
we'll
is
have-
great.
Good.
Alright, cool.
You bet.
Thank you, Randy.
You bet.
Zach.
Yeah, kind of thing.
Nice to meet you, thank you.
All right, you signed in?
Yeah, thank you.
You bet.
Yep, I signed in.
I feel like you've used this on a couple different classes.
Hey, it's a good display, it's a good display.
Same one.
I have a question, this is coming from a point of